There we go. Now we got the recording going. So, hello and welcome to the summer 2025 critical infrastructure cybersecurity workshop here with Summer Working Connections. My name is Jason Zeller. I'll be kind of going through this week, and we have lots of people in attendance. It looks like about 19 now. So, if somebody joined up, I need to make sure I get your attendance. As I mentioned earlier, speaking on attendance, they really want us to make sure that we get attendance in the morning and in the afternoon. So please make sure if you're not sure that I marked you down, that I have marked you down so that you can get that credit for being there. Up on the screen, you should be able to see what we had planned for this week. So this workshop track is kind of tailored for beginners all the way up to seasoned cybersecurity enthusiasts and looking for a comprehensive introduction to cybersecurity within critical infrastructure and doing some hands-on labs. And so if you were a part of last year's workshop, those participants kind of jumped into a bunch of different labs that kind of evolved from building this lab set that's available from Network Development Group. And I wanted to kind of expand on that. One of the big things that came out of that workshop last year was a lot of students wanted some capture the flag type stuff or some more curriculum or some more materials that they could use in the classroom. So I really want to make this, the title is a workshop, right? Which means I'm not just handing things out to you. We're all going to kind of work a little bit together to come up with some of those additional materials. I have some pre-built, but I obviously wanted to get everybody's input, and everybody utilizes those materials different in the classroom. So we do have the access to those labs, and you guys will get lots of hands-on labs as we go through here. This does mention the quote new power plant portion labs. Unfortunately, the project that we were working with in Cassia and a couple of the others, or the power plant company, kind of fell through. So there's not as many labs in that realm, but we've got tons of other stuff that we can kind of get through there. It's really designed to kind of accommodate all skills going through there, so it doesn't really require previous knowledge of ethical hacking. If you have that, great. If you have some background in virtualization, things like that, it's going to be a little easier for you, but we can definitely walk you through a lot of the concepts. Um, One of the main things that we're trying to do is grasp that nuance difference between information technology and operations technology best practices. So a lot of schools, most of you, I'm assuming, are from the IT space, and you're looking to add some OT type concepts or classes or full-blown classes in the classroom. We're going to work through some capture the flag experience, and you guys will be able to utilize that in your classroom. We'll also utilize a little bit of an AI large language model, so you can have students as assist in answering those questions using AI. I don't know how many of you guys have used large language models and AI in the classroom. I know AI is like a big buzzword, but it is useful in the classrooms, and we have some ways of making it useful in the classroom here. So I want to be able to show you at least what we've done a little bit here at Fort Hays. And then a lot of these labs are going to be all available to you guys at no cost. So I'll send out some links when we get closer to there. These labs are available to you. How many of you are NetLab Plus customers from NDG? Is there a way to raise hands? Or there we go. Yeah, if you could raise your hand in the section there, and then I can kind of get an idea of how many NetLab customers we have available. Gotcha. Okay. So we've got about a third of you guys, it looks like, that are familiar with NetLab and how NetLab works. And then how many of you guys, anybody use their online services? A couple of you, it looks like, in there. Okay, great. So we're going to be using a lot of that platform in this environment. I know for those that, and I'll talk a little bit about this on my background here, but I used to work with NDG and trying to build out these lab sets and get them out to classrooms. So I know a lot of you utilize those systems. And if not, I'd be happy to kind of walk you through what those entail. For those of you that are NDG customers or are in the process of changing out the entire infrastructure due to VMware stuff, I'd be happy to kind of visit with you on that throughout the week as they start to roll out their Proxmox background and such. All right. So that gets you out here to the Engage platform. Most people are always asking if I'll post the PowerPoint, so I'll try to be diligent about posting the PowerPoints out here in the resources. I'll be honest, I'm not a big PowerPoint person, so in the first 2 days here, we have some just kind of as placeholders, but the rest of this is really meant to be a workshop. It's not a let's listen to a PowerPoint and do this all day long. I can't stand that, both as the other side where I'm listening to it, or if I'm on this side teaching it that way. So we'll cover a little bit just to make sure everybody gets their background and their resources. But I please remind me as they now have this nice Engage platform for me to be able to submit some of this stuff up there. Every day, it'll kind of give you an idea during the agenda of what we plan to cover. Most of this is going to stay pretty accurate. If there's any changes, I'll let you know. If you guys have any questions over here in the lower right-hand corner, it looks like many people are talking, and I've been in there too. So please let me know if you have any questions or something comes up after the workshop, during the workshop. I'll try to keep an eye on this side, but definitely utilize the meeting chat there as well. All right, let's see here. Make sure. I was probably sharing that, but not sharing the screen, so we should be good. Great. All right, so can everybody see this center section here, the PowerPoint slide?
Hey, Jason, Tom's had his hand up.
Yep, okay, great. All right, so a little introduction on me. How many of you have attended any kind of workshop or anything I've done in the past? Or am I completely new to everybody? Okay, great. So good, you guys get to experience me for a week. So those that don't know anything about me, and it's a little bit different being down in these Texas workshops, as I've done so much on the West Coast over the years that it's been a while to come down here and kind of work with the Summer Working Connections, and I'm honored to come back here a second year and kind of work with everybody. So a little bit about my background. I'm now a full-time professor at Fort Hays State University up here in Kansas. I kind of, I guess I'm the lead faculty for the cybersecurity side, and they recently gave me this fancy title of Director Operations for the Cybersecurity Institute. And then I'm the co-director for our Center of Academic Excellence here as well. Those are all titles. I'm a pretty easygoing guy, and you guys will get to know that this week. That I'm not hard and fast in what we're trying to learn here. My goal is to give you the max amount of materials and the things that you wanted coming into this workshop. So I have an idea and a plan for the week, but if we end up getting consensus that we want to go a different direction or cover new materials or something different, I'm more than happy to accommodate that. I don't know how many times I've been in these workshops. We get in here and it's completely different than what we originally intended, but everybody in the workshop was super happy that they got what they wanted out of it. So if I'm not covering something that you wanted to cover, by all means, drop me a message in the chat. You can send me an email, however you feel comfortable doing that. I'm more than happy to accommodate in that side. So as with many of you, I'm sure your summer work is super busy. There again, a little bit of background on me. So I used to work for Network Development Group, or NDG, for about 8 to 9 years full time. I worked with them shortly after I was out in industry, and my role in that job was to build custom labs and content for all of the different platforms and systems that they had at the time. I also managed their network and their infrastructure and some of the deployments we did there. I still go back during the summers and help them out, especially this summer. For those of you that are familiar with that platform, the VMware, when it was purchased by Broadcom, pretty much pulled the rug out from all the schools that had VMware Academy as part of their school. And then, of course, pulled out all the VMware licensing with it, associated with it as well. So we've made some big changes to try to move that over to a Proxmox backend. And because we only have about a third of you that kind of are familiar with that NetLab product, it's an online lab service that you can either purchase from the online side, or you can purchase a system that you host locally at your institution. And it gives you a ton of remote access to labs. And there's a bunch of different content that's available. depending on the different labs and things that you guys are familiar with. So I'll pull that up here, that one. Again, if any of you aren't familiar with it, it would be just netdevgroup.com. And you guys can be familiar with either the NetLab Plus product and the full content list here, as well as the NDG Online, where they offer a lot of the same labs online if you don't actually own their system here. And I kind of bring that up here because all the labs that we're going to be going through here are going to be provided from NDG for free. You guys are going to get free access to those. Some of that I host here at our facility, and we'll kind of switch into those about midweek. But NDG was kind enough to make sure that we had tons of online access for everybody in the workshop. So you guys should be able to get access to those. I believe you'll have 30-day access to those labs. And if you need additional access beyond that, you can always message me and I can work with them, or I can host them here at Fort Hays as well. Those that are in the process of migrating to the Proxmox backend, you can see a little bit over there on the left as to the new solution and how that's all going to get laid out. So I can spend a little bit of time on that if somebody's interested, because I know a lot of you are trying to get your custom labs or your custom critical infrastructure stuff moved over to the new backend, and that is quite a process. Other work that I tend to get done during the summer, I mentioned City, and I believe last year down in Texas, I kind of talked to everybody about what City is and what we're doing there. One of the big things in terms of cybersecurity, as well as in critical infrastructure, is we have some really cool VR things that we're working on for students in the classroom, where students can strap on a headset. It dumps them into a given building. Right now, it's like a little cabin out in the woods, and they have to actually go in and wire the IT infrastructure in that cabin. And so it has a grading system built in where it makes sure that you're actually running the cable the right way. And then we put in, issues like concrete and different walls, different scaling power lines crossing it. And so they have to find the right way to deploy these environments. Some of the other steps when it gets to critical infrastructure is basically being able to do this inside of a factory, and how networking and cybersecurity would work inside of a factory type setting. And then there's also the physical access side of it too. So being able to wire up door sensors and setting up door access, remote access control, that kind of thing. They can do that all in there as well. And then when I'm, of course, not busy doing all of that, I have a small little cybersecurity company that I work with a lot of my students. So I tend to hire either high school students in the area or my college students here. And we're responsible for deploying a lot of the network infrastructure at some of the businesses and some of the large places around us, primarily using Ubiquiti gear in which we deploy there. And then they do everything from camera security to door access controls to infrastructure and networking, access points, etc. So I stay pretty busy during the summer, and I'm glad that I was able to get a workshop with you guys. I just got done with 3 weeks of workshops trying to train everybody on the new NDG platform. This is a little bit of what we're looking for in terms of the agenda. So today our goal is to kind of cover OT and kind of a Linux review. How many of you are familiar with the concepts of OT and critical infrastructure? Or is that what you're here at the workshop to learn? Okay, great. So I saw that in the initial survey that we had there. And so it's really important that you guys fill out the surveys because that really helps us give some feedback both to Summer Working Connections, but I'm also taking that feedback so I can kind of redo some of these workshops based off your guys' feedback. So I'm really, really open to feedback. Don't be afraid to give me, it's great, it's horrible, you really need to fix this side. Really want to kind of make sure we tone that in there as well. So we'll cover some OT and some Linux. And then we'll do some continuation of that tomorrow, just kind of wrap up some of the labs. I'll give you guys access to some links and things like that beyond the lab sets I have, things you can utilize in the classroom that a lot of instructors have had success utilizing in that regard. And then by Wednesday, like I said, one of the big deals that people wanted to work with last year, we went off on many tangents in that workshop, from going from the critical infrastructure side to full-blown ethical hacking and some of the labs And then, of course, lab sets that are available out there that you can utilize. But the CTF, the capture the flag side, is really what people were interested the most. So I tried to dedicate a little bit more time with that. How many of you run capture the flag type of events at your institution? Michael does there. Carl. Okay. And those of you that don't utilize capture the flags in the training materials, is it just you haven't had the chance to set one up, or you're looking for information on how to do that? Skyline and Cyberforce, great. Okay, great. So you're looking to host some for either your students or maybe other schools, that kind of thing. How to do it better? Yeah. So I'm not going to say I have the perfect ways of doing that, but I can tell you I've spent the entire weekend, of course, with other hours here, trying to rewrite some new software to make it really easy for you guys as instructors and myself as an instructor to deploy some of these CTFs and make it a little easier for us to spin them up faster and better. I've done a lot of them over the years, some of them for NDG so that we can utilize it in the NetLab platform, and really trying to get schools to utilize more capture the flags in that regard. Whether it's a full-blown capture the flag where you're actually chasing down flags inside of VMs and that kind of thing, or even if you're using it in a small structure to be like a Jeopardy style capture the flag. And then we'll talk a little bit more about that during those days. But I've had myself and a lot of students work with me in building these out for different workshops. We build them out for different conferences so that students can have access to those as well as attendees, and then give away some good prizes there as well. So we'll talk about that on Wednesday and Thursday. And then we'll build some of those challenge labs with AI assistants. So how many of you are actually utilizing AI in the classroom in some regard, whether you're utilizing it for the students or you've used it to help you write content and curriculum? How many of you are familiar with the concepts of AI in terms of large language models? Chat GPT, Gemini, those kind of things. Okay, small handful, about 4 or 5. Great. Yeah, so Terry, you're right. With sites like CTFD, that's definitely going to be one of the ones we're going to talk about and work with. Root the Box, Hack the Box, Pico. Yep, those are all great ones. Yeah, CS2 AI, great, fantastic. And so Friday is really going to be focused on getting that assessment done that's in there, distributing all the materials and things that we create this week. So generally when I get into those CTFs, there's kind of 2 big goals that I've had there. Is one, we build out essentially a CTFD instance that you can deploy at your institution, you can utilize in the classroom. If you don't have the ability to do that, I am going to host some of that for everybody in this workshop. So if you don't have the ability with your IT group and stuff to host that, I plan to host anybody that attended this workshop. I'll do that this academic calendar year coming back up here. And then, like I said, just kind of distribute my stuff around and work with everybody here. Is there anything I talked about here that you would like to see covered this week? And I know obviously this doesn't give you fine grained detail, but if there's something I didn't list here, by all means, please put that in the chat so that I can make sure we get it added to the agenda. Like I said, the way I run workshops is heavily based off feedback. So if everybody's super quiet, it doesn't work very well. I really need some feedback as to what you're looking for, and be a little more hands-on as we're going through this workshop. I know it's online, it's a little difficult to do that, but it's not anything that we haven't crossed as instructors or administrators in programs before. So most of you should have the kind of class schedule, but this is pretty much the breakdown for every single day. So we start about 9:30 Central Time. We'll end up taking a break there around 10:30, kind of running up to lunchtime. And then we have another little class and a break session down there in the afternoon. Again, they really want me to try to keep going till about 5:30. Last workshop, we ran through so much material that we were ending a little bit early, but they really want to kind of keep those out so you guys can get your Credly badges and your credit for what we're doing there. Yeah, that's great, JB. Let's definitely dive into that so we can see what we can build out for OT. Yep. So that's the other thing. If we want to get into more hardware and emulation and that kind of thing, I can run down the hallway and I'll change rooms and we can do some hands-on with some Circuit Python type stuff and build out OT type devices in that regard. I can switch gears and go down that realm too. So it's whatever you guys are interested in. That's what I want to make sure we get covered this week. I have some bulleted items and some materials. But like I said, after last year, it was such a great group working down in Texas. They just wanted tons of information. And I tried to share everything I've collected over the last 15, 20 years going through here. All right. Does anybody have any questions before we jump in on this side and see what we have in store? All right. Like I said, this will be the only PowerPoint type style presentation as we go through here, as I'm really not a huge fan of this side of it, but I do want to make sure people have some background on the OT side of things. So OT refers to operational technology, and it is the hardware and the software systems that detect and cause changes through direct monitoring, control of physical devices, processes, events, and usually in an industrial or critical infrastructure type of environment. Most of the hardware that you would see in here would be something like programmable logic controllers or PLCs. We'll get a chance to work with those in a virtual set here today in the labs. You can also have remote terminal units, RTUs, industrial sensors, and actuators. And then from the software side, you typically have a SCADA system, which is the supervisory control and data acquisition. Those are kind of software that oversees, you can think of it kind of like a dashboard as it goes through there. However, it's mostly just collecting the information. And then you'll end up with industrial control system firmware or ICS side of things. And then last but not least is those human machine interfaces, whether that is a panel full of buttons and displays, or maybe that's an entire screen that you typically watch everything happening in that industrial setting or even in the critical infrastructure side. Again, we get to design all of those and play with those in this week. So some of the core OT components that are out there is going to be your sensors and actuators. These are usually measuring some kind of physical parameter, whether it's temperature, pressure, flow, proximity as we're going through there. There's really good, and there's an endless amount of sensors that have come through here. How many of you have played with Packet Tracer and the different type of IoT type things that are available with Packet Tracer? JB, it looks like Tom Lee. Okay, great. So, and Gordon, great. So there's really good ways if you're trying to teach a little bit of critical infrastructure or bring a little bit of IoT into the classroom. The Packet Tracer is a great way to do that, and that's one thing I had as a list item this week. That if you're looking for easy ways to get these concepts into the classroom without buying full-blown OT gear, that we could utilize things like Packet Tracer in order to do that and have some activities that were centered around that. Actuators are another one. This can usually be used for opening valves or maybe starting motors, things like that in the industrial setting. And then we have to have controllers that tell these sensors when to operate or what they're doing or relay information back. And so those will be the PLCs and the RTUs that have the logic in them. If temperature is greater than X, close this valve or whatever else is going through there. And you'll get some hands-on labs where you'll actually write some of these logic controllers. And you don't have to be a full-blown, OT specialist to do this. There's some really pretty simple labs with some examples to get everybody going. So some core OT components, you're going to have something like that SCADA server that we talked about before. Again, this is collecting all the information from the stuff down below. Your HMIs, your human interface panel, this is basically your graphs, your charts, your dials, things like that. Typically all behind a firewall with some router information. the historian, something storing some of this data so that you can retrieve it. And then there's lots of different software in terms of communication that can be used on these networks. The most common one being Modbus, Profibus, or Ethernet IP. There are several others. Multiple vendors have their own way of communicating over those protocols. A lot of that in the old days was set up in a way that it was kind of a closed network. So it was great because you didn't have to worry about the hacking things that we hear today. But the problem is everything's gone to Ethernet, good or bad. And so being able to focus in on those protocols and make sure that we maintain segregation so that we can protect those networks is very, very important. So what are the key differences between OT and IT? And I should pause there for a second. How many of you on the raise of hands actually teach the IT side of the house? So whether it's the basic networking, like your Net Plus, your entry-level Cisco classes, that type of realm. Is that where most people's background's from? Okay, great. And I'll tell you what, one thing that I meant to do in the very beginning here, and I didn't, I I wanted to jump into material here, but if we could take a moment and just kind of, I'll call on you one on one if you want to answer, and just kind of tell me where you're from, what your background is, so I have an idea of where everybody's at. I meant to do that in the very beginning and got caught up in what I was doing here. So if I could start with Alyssa, if you want to kind of give an introduction of who you are and what your background is, that'd be great. And you're welcome to come off mute or you can put it in the chat, either way, whichever one's comfortable for you. And that was Alyssa Van Overstraten. Hope I got that right. Okay. I'm actually going to roll through my list here. So how about Nadia?
Good morning, everyone. My name is Nadia Bilal, and I'm a professor of cybersecurity, and I'm a discipline lead of associate program and advisor of a couple of chapters. I'm from Collin College.
Fantastic. Thanks, Nadia. Gordon Carnes.
Yes, I'm Gordon Carnes, Southern Crescent Technical College, Griffin, Georgia. Teach networking, PC repair, cybersecurity, programming.
Fantastic. Thank you, Gordon. Let's see. Did Chola make it in here? She's not quite here yet. I knew she had sent me a message earlier. So Rodney Cobb. I can see you here, Rodney. Did I put you to sleep already? All right, we'll spin back to you. Rafat?
Good morning, everyone. My name is Rafat Al-Sharif. I am from Milwaukee, Wisconsin, Milwaukee Area Technical College. Background is networking and cybersecurity, and been teaching there for almost 25 years now.
Fantastic. It's good to see you again, Rafat. Let's see, Yaritza.
Hi. So yeah, my name is Yaritza Garcia Rivera. I teach at Houston Community College, and my focus is networks and cybersecurity.
Fantastic. Great. And Kenneth Gardner, are you here? Okay, great. Keep my roll call going up here. Hector Garza?
Yes, Hector Garza from University of St. Thomas, Houston, Texas, and more on the networking side, Cisco specifically. But of course, there's a lot of security, that it gets incorporated into that, but a lot into the networking side.
Fantastic. Great. Michael Greer?
Hey, good morning, everybody. Columbus State Community College in Columbus, Ohio. And I primarily teach ethical hacking, web application security, some cloud, AWS cloud. So I've been teaching for about 8 years now and spent about 30 years in industry. Worked for Microsoft for about 10 years. So done a whole lot of things, but definitely focused on security for probably the past 15 years.
Great, great. And I got you marked down for attendance, so you're good to go, Michael. Let's see, JB Groves.
Can you hear me?
Faintly there, JB.
Okay. J.B. Groves III, Wharton County Junior College. I guess it's my ego. I've been in IT for maybe 4 years. I can't think of anything I haven't taught. I'm really not a programmer, I guess I ought to say that. I'm pretty much a hardware guy. And a lot of folks know me, I think, but my passion is light fidelity communications. I mean, I've gotten a grant where I replaced 94 computers here at Wharton. In the lab I'm sitting in, I've ordered a bunch of Wi-Fi equipment. And so it's basically a fiber optic and Wi-Fi lab that I'm sitting in. So, and that's all about quantum light security. That guy from NSF, that Light Rider, that I'm going to be doing his stuff. But anyway, I'm just going to keep working until I can't work anymore. I was in industry for over 26 and a half years. I've been here at Wharton since 1999. So, glad to be in the class. Appreciate it, y'all.
Appreciate that, JB. Your microphone's a little bit low there. I can kind of pick it up on my big speakers here, but if you want to come off of mute, you might double check your mic coming in the future, but glad to have you here. Let's see, Terry, and
You say Jerry Hilgenberg?
let's see.
You're going to go first,
Yeah.
Jerry.
Okay, all right.
You're up next. Terry Hand.
Hey, everybody. Terry Hand. I am the cybersecurity instructor here at Geechee Technical College in South Georgia. And I'm excited about being here. I really excited for my students. I run a lot of, we participate in a lot of competitions, Cyber Skyline, Cyber Force Skills USA. I'm looking forward to the Capture the Flag, interesting concepts. But the Net Lab's got my attention, so just bringing that up. And it's good to see everybody.
Sounds great. Yeah, by all means, let me know what you want to know and what you want to know. That was my bread and butter for many, many years. Still is. So, like I said, they still hire me back in the summers to come work on whatever they got to bring them back up to speed. So, let's see here, Jerry Hillenberg.
Yes, Jerry Hilgenberg. I'm a professor of cybersecurity at FSCJ, Florida State College at Jacksonville. Been teaching now roughly for about 5 years. Thank you.
Great. Thanks, Gary. Terry Holloman. Okay. James Huskins.
Yeah, Jim Huskins. I'm also at Florida State College at Jacksonville. I teach across 3 different curriculums, cybersecurity, programming, and applications. And, I've been teaching various places for about 30 years in the IT area.
Great. Fred Keller. Here, Fred. All right. And Wendy Klimt.
Hi, everybody. My name is Wendy. I teach at Gateway Technical College in Southeast Wisconsin. I teach in the Network Specialist Program, Cybersecurity Program, and the Computer Support Specialist Program.
Awesome. Glad to have you here. And Tom Lee. All right. So Tom's from Bellevue. He's a professor of IT, 2 years, and cybersecurity 4 years, as well as the program chair. And he's an operations specialist professionally as well when he's not teaching. Good to have you, Tom. Carl Lindermouth, or Linda Roth, I'm sorry.
You bet. Carl here, 24 years of teaching. I was an IT director before that for a mid-sized state agency. And then I've been focused on pretty much cybersecurity and system administration, Linux and wireless. I'm the only one that teaches those classes.
Awesome. Those are all good classes, and I love them myself. Let's see, Shankar. Robbie? Robbie? I know you were asking there in the chat.
Yes, sorry, I just was thinking about this. Okay.
No problem.
Shankar Ravi from Northwest Arkansas Community College. And yes, I'm unmuted now, so that's good. So, 17 years, cybersecurity, networking, information systems, and data sciences. I'm the chair there, so trying with OT and IT integrations now, so trying to get it into a CTF model. So, yep, it's me from Northwest Arkansas Community College.
Fantastic. I like to hear you integrating in the CTF stuff. That's great.
Yes, sir.
The Greg Robinson.
Hi, I'm Greg. I teach at Pitt Community College in Greenville, North Carolina. I've been here about 25 years. We have an associate's degree in cybersecurity. We're a CAE. I'm the point of contact for that. We also have NetLab Plus and struggling with ProMox, trying to figure out what we're going to do. About it for me.
Great. Well, if you have questions, Greg, on getting into Proxmox and that kind of stuff, by all means, let me know. Like I said, I just got done with those 3 weeks of workshops trying to get admins up to speed. And we do have some other workshops coming up here again to try to get everybody moved over here before that August 31st.
We're still waiting on NDG to provide us some info from their beta stuff.
Yeah.
There's an update to 24 and we're at 22 and there's no way to update to 24. So we're just kind of.
Oh, no, we can definitely get you up to 24. So by all means, shoot me an email and I can get you up to speed on how to go from 22 to 24 and then get you ready to go to 25 so we can get you up. So by all means.
That'd be great.
Let's see here. David Rossi. Did David show up? Rafat, the next training for that, I think honestly it starts back up again next week. So if you want to email support at NetDev Group, they can get you that training schedule back out. Debbie Todd.
Hi, I'm Debbie. I'm an adjunct with the University of Arkansas Rich Mountain Community College. I help to teach IT courses. Mostly those are Microsoft courses at this time. I work in the IT department as an information security risk engineer within the college. I'm excited about this workshop and hope to be able to bring new courses and new information to the table for our IT department and to the college for possibly new courses to offer our students.
Great. I like an eager adjunct, that's for sure. And let's see, Alyssa, it looks like you're back.
Yes, hello, Lisa Van Overstraten from Clark State College in Springfield, Ohio. I manage the cybersecurity program and the point of contact for the CAE. And really, I am here I try to make sure that we are offering a broad base of foundational knowledge. So I kind of go to some of these sessions to try to expand my knowledge to make sure that we are providing a strong foundation for our students. So I'm excited to learn.
Sounds great. I like when program administrators are doing that because it's hard to keep up on the new stuff. It's very easy to fall into what you've taught for 10 years and it's always worked and don't rock the boat.
Yeah, but you get behind.
You got it, and you can get behind really quickly. At 4 days here, I have the pleasure of most of my colleagues were actually my instructors when I went through here as an undergrad and as a grad student, and was fortunate enough that they decided to keep me on after I went through grad school as an adjunct and then later as a full instructor, and trying to get some of them to change their course materials. I got to rib them every now and then. Hey man, you taught me that 15 years ago. What's happened in 15 years? We got to change that. So it's great. It's good to work with instructors all around, and it's good to see that people are trying to stay on top of the new stuff. It's very hard to do, and that's one thing I want to stress in this workshop is I don't have all the answers. I don't know all the answers. The only thing I come close to having all the answers on is around some of the NetLab Plus product line, just because I've been around that for so long. But when it comes to critical infrastructure and IT and all of those, all I can do is share the access to the materials and all the things that I've covered either in my classroom or working with other instructors such as yourselves, doing so many workshops over the years during the winter breaks and during the summer breaks, during the school years, things like that. And I've been fortunate enough to give them all around the U.S. And so I met lots of people that have really good information, lots of great subject matter experts that are out there. So again, as I mentioned there, sorry I didn't do that in the beginning. I fully had that on my check sheet there and skipped right past it as I was rolling through some other stuff. But it's good to know most people's background is at least somewhat in the IT realm. And I know as you folks that are program chairs and things like that, you may get the pleasure of teaching a course, or you're at least trying to bring some information back. So a lot of this is going to get super technical. And if you're not as technical as you once were, or trying to be, or at least keep up on those materials, by all means, take some screenshots, take some things that you need along the way. And then if you want to refer your staff or your instructors or whoever out there to get in contact with me to kind of go over some of those materials, I'm happy to do that as well. It's not a problem. So to kind of compare IT and OT, one of the main things on the purpose there, in the IT realm, we're always trying to manage, store, and process digital data. A great way of putting that, for example, our department here at Fort Hays State University is the Department of Informatics. And that Department of Informatics started as news and radio, TV, and then the computer networking and web and mobile development. That's really what it started back in the late 90s. Since then, the department has grown tremendously in the number of concentrations and things that we cover. But the main focus there, if you'll look across all of it, is it really focuses back to this concept and purpose of IT. So whether the radio news station was creating the content that goes across the wire, then the networking guys need to make sure that that content makes it across the wire in a great way. And then, of course, you have the UI front end from the web development people in order to make sure that this newfangled thing called the internet was going to actually be able to display that. And of course, this is 25 some odd years ago, probably 30 years ago when that department started. So it's nice to see that IT is kind of well-rounded in those. And I've heard from a lot of schools that you all are trying to design programs in a very similar fashion, making sure that they have that well-roundedness. When it comes to the OT side of the house, that's where, you get into their main purpose is to control and automate those physical processes. And what you'll start to see here, specifically in that security focus and into the life cycle and standards, is on the latency side, we're pretty tolerant of latency, and we can go to milliseconds to seconds. In OT side of the house, it has to be pretty much real time. And so a lot of what you'll see, like in the labs, we'll even use Linux to emulate PLC controllers and SCADA and such. But being able to do that in real life or use that in real life just doesn't work because you really need that real-time access. So we could create virtual machines to emulate this, and it's great for the classroom. If you can get students some hands-on with some actual PLC controllers, we'll talk about Click PLC controllers. Those are pretty reasonable to get into, and the basics of what they can program and still be at a real-time platform. Even the Arduino and stuff like that is a great one to get onto. Raspberry Pi is a little bit different because you're utilizing that underlying Linux structure. It's not necessarily a real-time operating system. So you're going to get a little bit of that latency, and you'll actually see it even on a little Raspberry Pi, some issues in that and tolerances in there. Life cycle wise, we're pretty short in the IT spell. We're 3 to 5 years and all the tech changes. In the OT side of the house, it's 10, 20 years or more. And sadly, you're going to go out and see a lot of OT that is still running Windows XP and absolutely cannot get away from it because the software and things that we're running just run on XP. It may not have access to the internet anymore, but it's still going to run under those old systems. A lot of times, administrators, from what I've seen and heard, are basically remoting into those systems or physically going to those in order to get access to them to prevent that. And we're actually going to, in these labs, we'll actually hack our way clear down into a PLC controller sitting from the corporate network, which, because things are trying to get more integrated, is entirely reasonable if there's some bad security policies in place. Standards wise, we have our TCP/IP, HTTP, SQL, that kind of thing. On their side, they're going to have industry specific standards that go through there, but it's really the security focus is what I want to kind of look at. And on the IT side, those of you that are CAE schools and things like that, that are teaching the cyber side, we always talk about the CIA triad, right? And that is your confidentiality, integrity, and availability. In the OT side of the house, they're very much focused more on safety, availability, and integrity in there. So there's some overlap, but what they're really focused on is a little bit different in that realm. And so speaking of that security triad, what we're really trying to focus in there is, on the IT side, we're always worried about usernames and passwords and things like that. On the OT side of the thing, it's really safety, how many safety controls or backups to these systems are there. And so in the event this sensor fails, what kind of safety feature is going to kind of make sure that, we're not overfilling the tank that is carrying a toxic caustic chemical and it pours all over the floor or whatever's going in there. We got to have a bunch of safety measures in place. In the availability side, it's got to be, we always talk about 5 nines and that kind of stuff in the IT space and think that's great. On the OT side of things can't go down. When you get into critical infrastructure, if you shut down the traffic networks or you shut down the water plants and facilities, and even worse, the power industry, people are going to get hurt or maybe even have loss of life when those type of systems go down. Think hospitals and things off life ventilators and things like that. When those systems go down, there's lots of people that are affected in very bad ways compared to the IT side of the house. And then, of course, making sure it's all integrity is solid and working our way through there. So on that safety and reliability, OT failures can cause physical harm, environmental damage, or even large-scale outages. Critical infrastructure side, our power grids, our water treatment, transportation, manufacturing, all of those rely on OT. And we've all seen that here in recent years, just how vulnerable those systems really are. In our labs, we're going to primarily look at a water treatment plant. And so these labs were actually written in conjunction with CASIA, the Critical Infrastructure Security Agency, Cybersecurity Infrastructure Security Agency at the government level. And then you also have, I had a grad student that works for a water treatment plant that's kind of responsible for all the OT side of things. And they really helped us build in what they see in real life and where they're starting to get security vulnerabilities. So those are all kind of baked into the labs you guys are going to go through here today. Our goal was to bring in some power stuff, like I mentioned here at the very beginning, but we're still in talks with some of those plants, and we're really working on making sure that we can get those in the future. Right now, the big focus is trying to get all these schools up and going for all their lab environments. And then how this all converges with IT. And so Industry 4.0, we've all seen the industrial Internet of Things grow. OT and IT networks are just increasingly interconnected, making us do new security designs and challenges and how we're going to make sure that those systems stay secure. You're taking a network that really did not care about security. As a matter of fact, for a lot of the old OT stuff, there were no such thing as passwords or usernames or things like that to get into systems because you had to have physical access in order to get there. And so the physical access was more access control from the IT side to make sure people stayed out. But once you're in those networks, there never used to be username and passwords. And so you'll find that on some of the newer PLC controllers and things like that, that yes, they have the ability to do things like usernames and passwords, but they're usually very generic and they're not very secure. And that's because those controllers were never designed or have the CPU power to do some of the things that we take for granted today, like simple username, password, or a two-factor authentication. It simply can't do that. We're talking about processors that run at 60 megahertz or 110 megahertz, and they're really tied up in making sure that they're providing full availability, like JB said there, 11 nines kind of thing. That's really what matters to them, not keeping the system secure. And so that means there's a ton of vulnerabilities on the OT side of the house. As things get upgraded, it's great. But the problem is like we saw in the life cycle, it can be 20 years easy for a lot of these systems to get upgraded. simply because you just can't take them offline. You have to have hopefully some redundancy, and a lot of times you don't. So you just simply can't take it on offline for even maintenance. Is sometimes a challenging thing. My father runs a small a water treatment type deal for a small town back home. And even on the very small end, I'm talking a town of 300, 400 people, you still see little things like this OT side of the thing come into play. While he doesn't actually have to log in and do the PLC controllers and the SCADA, somebody else does, they have to do a remote desktop session to some of this. And yes, it is running Windows XP in order to get in and do some of that activity. And so when he's telling me that, you know, we just hooked it up to the internet temporarily and let them remote in, that's a bad deal. I sigh, because even the smallest towns that I'm seeing do this without thinking about the security implications. And we've already seen that, you know, down in Florida. We'll talk about that in some of our labs and such, that it's really easy for these hackers to take over these OT, the critical infrastructure side, because they were simply not built with security first. So how many of, I think I said about 3 or 4 of you have really worked with OT before. How many of you have actually had hands-on with a PLC controller or are familiar with PLC controllers? Mindstorms, okay. So at a very simple level, how many of you have a pellet smoker grill, Traeger, something like that? Nobody grills? I know we got Texas people down here. Come on now. Although you're all Texas people and not actually using Traegers. I get it. All right. So, all right. So there you go. Pit Boss, etc. All those would work great. So and I'm a big barbecue guy. So I when I'm not doing all this other work you see, I used to cater and do a bunch of other stuff. That part of my life has unfortunately dwindled down, but it used to be a big hobby for many years. The reason I mention those type of grills and smokers and stuff is they're using the most basic form of controllers, like a PLC type thing in them, which is called a PID controller in there. And that's what's really there to help make sure that they maintain this constant temperature that we're always looking for, right? So if I'm setting my pellet smoker to, say, 250 degrees, in order to feed the amount of pellets or the amount of fan that blows in there, all help dictates whether or not I need more fuel or I need more air. At its basic system, that is kind of like what a PLC operates on. So we're going to take a bunch of sensors. In that case, it's monitoring air. It could be monitoring flow of pellets, that kind of thing. And then does some calculations based on those, and then has outputs to either trigger the actuator, or in some of those, they're triggering the fan devices so that you can actually maintain that nice even temperature. Some of your ovens use something similar to that. However, most ovens do a really big swing. So those of you that cook in an oven know that it could swing 25 degrees pretty easily. Where on a pellet smoker, the really good ones, or the ones that are tailored in with nice controllers, they can usually stay within 2, 3, 4 degrees, which is pretty hard and finite to keep that. So I use that in the classroom, as a lot of students are at least familiar with those concepts. But a PLC is a programmable logic controller. It's kind of in a little industry controller that's designed for rugged environments. So it's meant to work in extreme temperatures and lots of other places that we wouldn't normally see computers run, especially down on the factory line. And the functions of those are to continuously monitor those inputs, whether it's sensors, switches, etc. It'll execute some kind of control logic, whether it's ladder or function block code. We'll talk about those in the labs. And then it drives some kind of output, whether it's a valve or turns on a motor or signals an alarm, whatever's going to happen in real time as it hits that block of code. And we can do a little bit of this in the IT realm. We've done this with, say, Python. How many of you are familiar with at least Python language or some kind of scripting language? Okay, about 2, 3, 4 of you. Okay, great. So hopefully most of you in the cybersecurity realm have some form of Python in your content and in your curriculum, because it's really, really important that the cybersecurity guys know Python. There's other languages out there, yes. However, Python's pretty much a big one, and I've had to prove that case multiple times. Here at our institution, the computer science department, 10, 12 years ago, we told them, hey, could you please start teaching Python? And they're like, nah, that language is never going to take off. Okay. So we took over Python and we started teaching it in a small scale. And when I came over here, that's when our Python really started to explode. I got it revamped, rebuilt up, and all of a sudden we're, teaching 100 students a semester easy to 150 students in some cases. And it's from all over campus. What they realized and failed to realize at that time was not only was Python big, but I have nursing students taking Python classes. I have physics students taking Python, et cetera, in those intro classes, because they all have to use it in some form or fashion. Some program that they're using in photography and stuff, they got to crunch a bunch of photographs for GIS imaging. They're using Python to do that. In the nursing side of the realm, you'll see some of these small hospitals, and I live in this rural area where you may be a nurse, but you're also the IT person that's also running the security side of things. Like, we just don't have those big infrastructures around here. And so rural communities are really focusing on making sure that they have a lot of those skill sets to take advantage of. And so Python has been huge for us. I went from teaching 4 sections of that alone a semester on top of my other 3 or 4 sections to really kind of spreading that out across other instructors here in the last years. They wouldn't let me stick with 7 sections anymore. But it's really, really popular. So I encourage you guys to add that if you haven't done that already, because it's a pretty popular language. It's used universally. Very easy to teach too. Very, very easy to teach. I have lots of materials for that. So if people need materials or access for that, I'm more than happy to share that. Most of what I use in the classroom is all open source there as well. But I bring that up here on the PLC. No, JB, I haven't seen that. And that's actually one I had heard that they were coming out with something on the OT side. But that's great. I would love to dive into that and see what's all in that. As a matter of fact, we'll pull that up here. Don't let me forget. And let's see how that overlaps with some of the labs and things that we have available to us, and what that may look like on that side. Example uses of a PLC. So you might have some kind of robot pick and place. A good mixture of where I used to see this on the assembly line was before my dad was doing the water tower stuff. And during his retirement, he worked for a Philips Lighting, which makes your 4-foot and 8-foot fluorescent bulbs. He worked in the factory for 30 years. And so I got to see these assembly lines and the IT side of the house when he was there. And being able to see these PLC controllers live. He was far from an IT person or a computer person, but even he had to deal with these old OT type systems, these PLC controllers. And so it's interesting to see that they've now moved to the IT side of the house. You'll see this in batch processing, like chemical mixing ratios, continuous feedback loops of temperature and pressure regulation. That continuous feedback loop I'm talking about is that PID derivative of the example with your Traeger smokers and things like that. They all use that type of logic built into them. And so some key benefits there is going to be making sure that you have really good response time, low latency, robust against electrical noise, vibration, temperature extremes, and reprogramming that in there. So the reason I bring this all up in the PLC side is it's extremely important on the latency side of the house, right? If something makes a change, you want to make sure you shut that motor off or shut that valve off right away. If there's a delay in the communication between the switch or the sensor and the thing doing the controlling, or even the other direction, the thing that's doing the controlling back to the actual output, you can cause some serious problems. And we're actually going to create a simulation of that inside the labs, where we start introducing some latency, we start overriding sensors and telling it and giving it false information, that kind of stuff. A lot of people think that, oh, we hack into it and we got username and passwords and now we're out. In the OT side of the house, just them poking around and doing things can literally take down systems because they were not designed for it. So here's kind of a breakdown of the main controllers that you would see within the OT environment. A PLC is typically doing some kind of discrete sequential controls. You'll see it on factory floors, machines, conveyor belts, things like that. Their main communication is going to be either Ethernet, which could be over Ethernet IP. We'll talk about that. Field bus, and so they could be using Modbus or Profinet. Again, a lot of these different vendors have their own communication networks that you'll see. Typically with PLCs, they're going to run about tens to hundreds of I/O points, and I/O being your input outputs. So again, your inputs are things like sensors. Your outputs are going to be things like motors or actuators or alarms, that kind of thing. And then you see the standard programming languages that are over there. RTUs are typically used for remote monitoring and wide-scale SCADA networks. From the IT side of the house, you may see these like at gas huts at electrical power plants, or your power companies may use these in remote areas. If you were part of telephone companies back in the day, they used some kind of RTUs to kind of give temperature readings in data centers or remote huts that are in the far end. That typically uses that same type of technology. You'll tend to see it in pipelines or water treatment plants. They'll use radio signals because they're usually covering vast amounts of area, or even serial links going across there. And that would be your Modbus and your DMP. And then those will have like hundreds to thousands of remote IOs, simple logic scripts, and we'll talk about doing some of those simple logic ladders. And then your DCSs, those are the big ones. Those are typically your continuous large-scale process control used in refineries, power plants, chemical plants, things like that. They use a high-speed field bus or even proprietary networks, and they scale to tens of thousands of IP point or IO points with graphical controls and advanced logics, things like that. So in a typical PLC architecture, and I've got even better slides that I can pull up and kind of describe some of this, but those power supplies are typically around the 24-volt regulation. You know, in IT and things like that, we typically use 120 to 40 volt AC. Almost everything in the PLC realm is DC. And you may have been in the telecom side, was pretty common to use 48 volt DC. But most of the PLC side of the house is 24 volt. The backplane itself provides power and power rails for the IO modules. So you tend to have, wish I had my little PLC here. I'll see if I can't find it here by the end of today. But you end up with a lot of little modules that go on a DIN rail. So if you're not familiar with a DIN rail, it's this little piece of metal about 2 inches wide, goes across. It's usually in a control cabinet. I can pull up some pictures here. But then you have all these little blocks that go in there, and every little block, little chunk of compute does something different. So it starts with the CPU, and then you'll have like an IO module, and then you'll have a alarm or sensor module, and keep coming down. Each one of those kind of expand off this DIN rail, and they all kind of get shared power from that DIN rail in some cases, but they can also do data input, so you don't have wires going across there. But that main CPU is meant to run whatever the control program is. It scans in a cycle, reads the inputs, executes a logic, and writes those outputs back out. And it's doing that, you know, 20, 30 times a second, or 60 times a second, or 100 times a second, depending on how fast you have that running. It contains memory, so it's got some own little RAM there and runtime. It's got some flash for program storage, and it has some host network interface controllers, whether that's an Ethernet port or a serial port. Mind you, these are very, very small machines compared to what we're used to on the IT side. So when we talk about RAM, it's usually in kilobytes, maybe megabytes. And the flash side of the house, there again, maybe megabytes. It's not like a full-blown computer that sits there that we're used to on our side. Usually they'll almost always have serial port communication for that. The newer ones are going to have Ethernet ports, and that's really where the IT side of the house comes in. But a lot of those are afterthoughts, meaning they weren't really designed to run with Ethernet, or they weren't really built secure. So simple things, and we'll talk about this in the labs, but me sending a ping out in IT is pretty common, right? I mean, we do it in all our classes, and we do it for checking uptime. Is that router or switch responding? Is the gateway responding? Is that computer responding? And it's no big deal. The computer handles that. But if we send a bunch of little pings at once, okay, maybe we can cause a denial of service or something like that on a host. It would take a lot of pings, like a ping flutter, in order to try to do that. When you do this on a PLC, if you send a bunch of pings all at once, it will flat out keep it from responding. It doesn't have the processor to handle sending and receiving those ping responses back. You will cause a denial of service very, very easily, and you'll get to experience that in some of these labs. Your I/O modules, we talked about this again. You'll typically have digital inputs; those are your DIs, and your digital outputs or your DOs. And so a digital input is usually reading some kind of signal, whether it's a push button or a limit switch or something that it's a simple on-off type thing. Your digital outputs are usually driving discrete actuators. So again, full on, full open, that kind of thing. No variance in between there. Usually used for like relays, indicator lights, things like that. Think light switch, on, off kind of thing. On your analog inputs, this is going to be using some kind of variable signal. So it's usually something to like 4 to 20 milliamps, over 0 to 10 volts from some kind of sensor. So temperature sensor, pressure sensor, those things, they typically are all analog sensors, and it varies the amount of signal that's coming from it so that we can see a monitor of what that's going through, right? We can't do a temperature sensor of on-off. It's got to have some kind of analog portion to it. And then an analog output. And a lot of time this will send variable signals. This would be like valve position. So whether we wanted a quarter of the way or a fourth of the way or a third of the way, that kind of thing, we can adjust those with analog. With a digital one, it's either off or on, off or on. So those analog. Another thing would be a motor. So if you wanted to adjust the RPMs on a motor, that would have to be an analog output there as well. Communication expansion. These are going to be additional slots that are used for specialty modules, whether it's high-speed counters, motion control, things like that. And then we'll have our network bridges there as well to kind of do some adapters. All right. So we're going to jump in a little bit on PLCs, but I was supposed to have you guys take a break here at 10:30. I'm horrible at breaks. Please remind me to take our breaks. So let's pause here for about, I believe they have 15 minutes baked in there. So re-drink, get some juice, coffee, tea, whatever you want to get, and we'll come back here in about 15 minutes. Hopefully we'll get through the rest of this this PowerPoint side of things. Like I said, this isn't my favorite part, but a lot of you are so green to the OT side of the house. I really want to kind of get you some background before we jump into these labs. All right, so I'm going to throw up a simple little timer here. I guess Zoom has this built in now, so let's see if that works. All right, there should be a timer running up there. I am going to pause the recording because we don't need to necessarily have that. Oops. All right. So a couple of things came up there while we were on the break. They were just talking about doing some PLC controllers and some automation and some different curriculum out there. And so one of them that came up was CompTIA announcing their SecOT certification, which I think is a great plan, and they're basically focusing on critical cybersecurity skills in OT. So I'd be curious to see what this cert ends up coming out with, particularly as they're looking towards risk assessment and compliance factory framework. So they're really covering some of the great topics that are in there. I'll be curious if it's more of a high level or a technical side of it. So it'd be great to see if we can have some technical side of it, because I'd be happy to write some labs or work with some people to write some labs with this and get that released out there on the NetLab product. That sounds like it's right up my alley. So a couple other things. We were sitting here talking about PLCs and such. And so sometimes everybody's visual learners, right? So if I do a stop share here, and everybody could probably see my screen, this is a Click PLC controller. So whoops, it's going to do the whole blurry thing. All right, we're going to ignore that, and I'll just share my screen and do it that way. There we go. So what this is just a little small controller, and I'm using a Click PLC, and this Automation Direct is a great place for you to get some of this PLC type gear or any of the sensors. If you're wanting to do some show and tell in the classroom, this is kind of a great place to go to get that. And they're going to have everything from the massive PLCs that are typically out there in industry to the little tiny guys that you can actually afford and kind of use there. One of the main ones that I've played with in the past are these Click PLCs. They work great. And so here's an example of one. Try to see if I can get it blown up here. This is the one I was trying to show you on my my screen, of course. Let's do that, that, and that. There we go. And so this is what's called a little PLC made by Click. It has a transmission port. Now, these aren't Ethernet based. There are ones in that lineup that have Ethernet here, and then it also has serial down below. These C1s, X1s, etc. These are going to be your inputs and outputs. So typically your inputs are the X's, your outputs being on the Y side of things. And you can control different I/O gear with those. This is just the controller itself. You'll notice here you have a switch, so you can program this thing on the stop side, and then when you flip that switch up to run, it ends up running that program live on the system. See if I can find an Ethernet one here real quick, because that pretty much is what most of us are wanting. Let's see here. Ethernet ports and a battery backup, serial. As you'll notice in the cost of some of these, most of them are fairly reasonable. This is a 192, but they make some that are, this one I have here, I have to look up and see what model it is. It's an ARE version of that. But this is very similar. So now you got an Ethernet port, a programmable port, and this here. This is your PLC controller that we've been sitting here talking about. You will still need a way to power it. So again, it runs off 24 volt. So you'll need to grab their little 24 volt power supply that's in there as well. That would look something like this one here. And so this snaps on to the left of it. And if I could show my my camera here again, that's kind of what it does. Is so this side is the actual controller. This side over here is just a little power supply. And so it takes in, this one takes in 120 volt. So it just has a regular Ethernet or server power cord that I wired into it. And then it will output the 24 volts that's necessary for all the extra modules. And so you just run some wires down from this, then integrate into the bottom side of this guy for the power side of it for your 24 volts. But it's great to utilize in the classroom. It's reasonable. I think the power supply is about $60. The PLC controller itself is, you know, you can find one here at all sorts of different pricing. I think the one I have is, let's see here, a 10 ARE. So let me see if I can find that one. ARE being, there it is, right there. So now they're showing about $207. I know we didn't quite pay that, but this is the one that I've used in the classroom, and it's pretty easy to work through. It gives you 8 discrete inputs, 6 discrete outputs, one of them being a relay. So you can kind of use this as a basic way to program it. What's nice is it speaks Modbus, which is great for some of the labs that we're going to be demoing here, so that we can kind of show you how to do that. It'll also do a little bit of Ethernet IP, which is great for there as well. And then, of course, you can program it and use their little Click Plus software in order to do that. All right. Get back to what we were talking about here on PLCs. So communication, like it said, additional slots, things like that. You would have an array of these in a bin. And then, of course, it's going to go down to a bunch of sensor networks. And then you're going to need to add the other pieces of it. So this is kind of a little question here. What happens if the PLC scan cycle takes too long? The amount of time it takes to scan, interpret, and then scan again going through there. And how might that end up manifesting on a production line? So for example, if you have a conveyor belt coming through there that's kind of misaligned, your input scan, your program execution, and your output scan is taking too long, you're going to end up with a timer mismatch, and you're going to have the robots are going to be doing things that they shouldn't be doing, or the belt goes longer than it should, dropping product, crashing product, that kind of thing. So PLCs are pretty important that side. which brings us to their attack surface, right? So again, we're cybersecurity guys and gals, and we're trying to figure out how this is applicable to the OT side of the house. So we have an attack vector over here where we have the Ethernet side, and ensuring these modules don't have open network ports that we can exploit, get unauthorized access, because again, in the early days, they didn't really have security on this, right? Or password was password, and you can't really change it kind of thing. And so to ensure those, we have to make sure that these things have the newer firmware patches that close some of the known vulnerabilities. But again, it's not like a router or a switch or a firewall where we can just take down the network for a short amount of time and bring it back up. On the PLC side, and when you're doing industrial controls, those systems very rarely ever go down in that regard. So I see that we had some more people come up here. Let me just double check my attendance sheet. Still don't have Chola there. Kenneth. There's Ken. Get you added and marked down for attendance. Ken, you want to kind of give us a overview of who you are, what you do?
Sure. I'm Ken Gardner. I'm with Spartanburg Community College. I'm an instructor here, mostly in Cisco stuff and cybersecurity, and I'm just happy to be here.
Sounds great. Thanks, Ken. Let's see. Fred's still out, and David Rossi. Let me get you marked down as attended here, and then if you want to kind of give us an introduction to yourself as well. You're muted there, David, if you're trying to talk to us. And if not, no big deal. You may have been one that messaged me that you were just listening in here for the first part this morning. So, okay. Just want to make sure I get everybody marked down so they get their attendance side. All right. So outside of that, we can end up doing port locking. So the ability to physically lock down and disable some of these unused ports, prevent rogue connections. It's pretty big on these type of systems, that we don't just leave it open for people to walk by and plug stuff into. And the biggest thing that we're going to find out is network segmentation, trying to completely isolate PLC networks from any kind of IT networks, and at the bare minimum, restrict some of that traffic from the firewall side. And the problem is a lot of this is starting to intertwine, right? So what I've seen and what I've had students, like I mentioned, out in industry, what they're seeing is these SCADA technicians or these OT technicians need to look up documentation. And before, they had a book. They looked up their documentation and did that, right? Well, now everything's on the net. And so they typically need at least internet to be able to do their job, look up for new firmwares, download packages, etc. And so they just started enabling internet on all these SCADA, workstations, etc. And that can be some very bad deals because they weren't plugging holes and they didn't have the best IT. They just need to get it internet and get out. But it doesn't take long for people to do attacks these days. And once they get that inside access, they pretty much can maintain that. And we'll show that here in the labs where we do just that. We wait for a SCADA technician to come onto the internet. They do it, we compromise them, we built in a backdoor, and then from there on out, we have the ability to take over their systems whenever we choose to. So it's some pretty realistic labs that we were able to design based off student experiences. There again, the main lab set was actually built off of an attack that happened down in Florida, I believe. And so we built an entire lab system based around that attack. Some of the programming languages that you'll see in here, and again, this course is not designed to get you to be programming language experts when it comes to PLCs. I myself am not fully 100% on these program languages, I can tell you that. I've done a little bit of these to do the labs kind of thing, but this is definitely not my forte here. But some of those standard languages that you'll see out there are ladder logic. It's basic kind of relay logic style. It's ideal for simple sequencing and switch control. This is one of the ones I tend to work with. Functional block diagrams. These are great kind of graphical blocks that you're used for analog and process control. Intuitive for PID loops. And PID is, again, what we were talking about there with your Traeger grill and maintaining the temperature. That is your PID controller that's doing all of that type of thing. Your structured text is going to be a high-level Pascal-like syntax It's best for complex calculations and data handling, information coming in there. And then you also have, whoops, sorry about that, instruction list or sequential function charts. This is kind of a low-level mnemonic code. It's state-based, sequence flow-based, used for really tight control and state machines for different industry type standards. So ladder logic is one of the easy ones to get started in, and that's what you guys will be programming some of the labs, but you will see examples of all of those there as well. All right. So when do you use these different ones? Again, ladder logic is really kind of this simple side. If you're doing complex mathematical logic calculations, you'll probably want structured text. If you're doing some low-level code, really want sequence control, that's what you'll see over here. And your functional block diagrams are for your typical analog process stuff. So that gets us into the labs. And so I want to get everybody access into the lab system. Again, Network Development Group, NDG, was kind enough to give us access to their online system as they're in the process of migrating this particular pod type over to the physical NetLab customers. And I actually just got those last night as I'm helping work through migrating some of this across. So I do or will have them deployed on the Fort Hays system here in the next day. I'll do it here this evening. And then we'll utilize some on the Fort Hays side. We'll also utilize their online side. But because they gave us the free 30-day access, I want to make sure everybody has access to that outside of my NetLab system here. So this link is going to get you access to the content. I'm going to put that there in the chat, make it easy for everybody. I'm also going to put it in the Engage side on the announcements. So I'll make sure you guys all have access to that. There's a total of 14 labs I want to kind of take you through today and tomorrow to get you some kind of background on PLCs and how this all works, and then how that really intertwines with cybersecurity and ethical hacking. And we'll actually do some of these challenges. And it's a pretty good lab set, I have to say. Now, it's a little biased because I helped design at least the last 8 labs that were in this particular lab set. The first 4 or 5 were really written by my grad student that does this day in, day out, builds SCADA systems, human interface controls, that kind of stuff. So he was really good at doing that. But the last 8, when it came to the cyber side, was taking what he built and really integrating that in with hacking those type of systems. So with this particular pod, you're going to see kind of the topology over there on the right-hand side. We have, and this is a standard network layout that's been out there and documented. It's the way they lay this out. So L5 is your enterprise level. This is where we're going to have our corporate workstation, our domain controller. We'll have a Kali Linux box that we would use to pivot through. The site business systems are on L4. L3, you're going to have your operations controls. This is typically where you'll have your engineers' workstations, things like that. And on L2, this is where you'll have your SCADA systems. Again, these are all segregated out there. And then on your L1 is your PLCs. This is going to be your Ethernet IP network, your Modbus network, things like that. So typically your PLCs will communicate up with the SCADA systems. Your HMIs, things like that will get pulled. And then the engineer workstation is purely getting dashboard type access to those type of things. It typically can't communicate all the way down to the PLC itself. And we'll be able to control some of that with the firewall, and the importance of doing network segmentation across all this so we can get a better idea of what's going on. So again, lab-wise, our goal today is to kind of get through the PLC and SCADA and understand what those topics are and get a little hands-on in that regard there. So the first one we're going to end up doing here is just kind of an introduction to those PLC controllers. And again, I'm going to get this link out to everybody, so let me steal that. That should be in the chat there. And let me throw that in the Engage system as well. All right. So with that link, kind Hey, Chola, I'll go ahead and get you marked down. Glad to see you made it. Hopefully your flight was a little more comfortable. All right. So let me pull up that link here and what that'll look like. See if it'll do it on this system without auto logging me in. And so that should take you out to the NDG portal. Now, in this case, it auto logged me in here. So I'm going to log out just for the sake of showing that here and then relog back in with that link. There we go. And so if you have an NDG online portal account, you can go ahead and log in with that. If you need to register, just click on the registration side and reserve an account here. The great part about NDG and such is they typically will give this kind of training out to instructors for free. So we always want the instructors to have access to all this. And then if they choose to use that in the classroom, then there's the ability for the students to either purchase that directly from them in the online side. They'll work with the bookstore, things like that, the schools. Or if you want to self-host those labs through the NetLab Plus system, you have the ability to do that as well. So this will take a little bit here. I'll give you guys about 5-10 minutes to get logged into this training system. If you need to register for an account, please do so. If you need approval, they know this is going on today. So they'll help me get that out if you guys are having any issues. The goal is that you should be able to get logged in on this side. And if all goes well, when you log in, there should be a button there that says enroll for free or try for free, that kind of stuff. And that'll get you fixed in the right system there. And eventually it should take you to a screen that looks like this. So you should have our 14 labs. And then if you choose to do so, you could click on this first lab and it'll go ahead and start a reservation for that first lab. So again, I'll give everybody about 5-10 minutes. If you have issues getting access to that system, please message me in the chat. You're welcome to come off mute. Anything else there that we can do to get you into here. It will take a little bit for this pod to boot up because it is firing up quite a bit of virtual machines. And this first lab, it's just 1 or 2. But as we get down towards the end, there's lots of virtual machines in this lab set. Goal here will be try to get through at least lab 1 here before lunch. And then after lunch, we'll come back and resume these labs here for the rest of this afternoon. Now, I do intend to kind of walk through the labs as we go through them here. So you're welcome to follow along with me on screen if you have that. If you want to do the labs yourselves and follow along, by all means, that's why you guys have free access. So please feel free to do that. If you have these deployed on your own system and you have a NetLab system, you're welcome to follow along with those too. So give it about another 5 minutes here. Does anybody have any troubles getting registered or access in? So once you get logged in, Terry, if you close that screen after you get logged in, then click on that link that originally sent you. It should take you straight into the critical infrastructure with the ability to click on claim free access. Oh yeah, you're fine. You're fine, David. Not a problem. Again, for those that want to follow along, by all means, click on the links, get your free access, all of that. You don't have to claim that today. If you need to do that here tomorrow, etc. Again, they've given us some pretty good access on that side, so it's not a problem. Yeah, I had to do the same, JB, and I'm there. So it's been a while since I logged into that online platform. Awesome. Anybody else having trouble accessing that wants access today while we're going through these labs? Now, I will say, because they asked me to do this newfangled assessment and quiz kind of thing, that some of the materials we covered this morning will be on the quiz. It's going to be pretty generic. It's not like I'm going to ask you exactly what protocol we used where. It's more of the main concepts that we talked about overall in the OT space. I will pull some of those questions out of these labs just so that we can make sure that you did the labs, as this workshop is really about making sure that you did the work and didn't just listen in. I was informed that I have to do it that way. And so if you guys are really looking for those Credly badges at the end, that you guys have to get an 80 or better on that final assessment, and I can't make it a cakewalk to take the assessment. That's what I was told. I'm not good at following directions either, so there's that. And while this is coming up, like I said, this afternoon, they're going to have you guys take some short surveys. I really ask that you take the short surveys in this class. How many of you are tenured professors? Is anybody here a tenured professor? Yeah, that's a fun process, right? So I am in the last year of my tenure process. So I kindly ask that you fill out these surveys as part of my last steps of the tenure is going to be used as this workshop. So some of the feedback in the surveys, as well as my PhD, I was told to go ahead and just finish that thing. So I would greatly welcome this, that you guys take the time to fill out those surveys for me. Yeah, I wasn't hugely excited about the PhD thing. I can tell you that. That was a computer science professor that told me I had no business teaching the Python because I didn't have a PhD. And so I told him I'd go get a PhD in 2 years with a 4.0 and I'll be back. And if there's further questions about using it in industry, I did that. I'll accept I'm like in the final stages of the dissertation. So I really just wanted them to go through and leave me alone, but I had to go get it. PhD is in cybersecurity engineering. So thankfully, I had taught 90% of those classes, so it was nice to go get that PhD.
You did it in 2 years?
Yeah.
My God.
Yeah. We had, like I said, all the way up to this dissertation, and then I had my youngest daughter, and so I took this last semester and stuff off. But it was a fast-paced thing. We were every 8 weeks was another semester, and I was taking 2 or 3 classes per semester. So it was a very fast-paced PhD. I can tell you that.
Do you mind? Can you tell us where you got it?
Yeah, it was from University of the Cumberlands in Kentucky.
Okay.
They have a fantastic PhD program there as we roll through. Yep.
All righty. Thank you.
Yeah, and I've actually had a lot of my coworkers go back, and they're getting their PhDs that way. And the grad classes that we teach here at Fort Hays will actually transfer in as credits going in there. I worked out a deal with them as another way because I had some students that wanted to go get PhDs, and we didn't do that on our side. So I definitely wanted to give them a place to do. And I went to several other schools that for the PhD and the application side to try to get that going. But so many of them didn't allow you to do it online, and there was no way I could go stay at some of these locations. I wanted to go to the University of South Carolina. I had connections there and some stuff, but just didn't work out. Cost JB was actually pretty reasonable. I want to say it's like 500 a credit hour or something like that. It wasn't much more than what our grad program here is at Fort Hays. So really reasonable through most of it. Unlike the first class I took from a place down in Florida, it was like 10 grand for the first semester, and I was taking 1 or 2 classes. I was like, this isn't going to work. So forgive me, I didn't mean to get off topic there. So I greatly appreciate that you guys filling out those surveys, as that'll help me through the tenure, but it also works in these workshops. So we truly care about the feedback. I know Mark and all the great guys at Summer Working Connections really are trying to put these on and give you guys the best materials. And so I want to make sure that I'm doing just that. That's what they quote unquote hired me to do, but I really enjoy doing these. You're welcome to start this lab, launch lab 1, Hector. Hopefully everybody can get to this screen. I'll stop babbling and we'll jump in there.
Thanks.
Yeah. Yeah, Rafat, I know. That's what some of my coworkers were the same way. They got all the way to the end and then they had a really bad what do you want to call it, supervisor or whoever was over their dissertation side, and they ended up dropping out because of that. I've heard that story over and over and over. So I get it. Having been through it, I totally get it.
Just going through the process is very painful. It took forever.
You got it. You got it. That's where I keep getting stuck now. I'm like,
I almost gave up at the end, honestly.
So is this called, Jason, is this called University of the Cumberlands?
Yes, it is. Yep.
Okay, great. Okay.
Again, not to get sidetracked, but I love to kind of tout them because they did a really good job in their program there. So yeah, University of the Cumberlands in Kentucky, and I was doing the PhD in information technology with the focus being in cybersecurity engineering. So. Yeah, I hear you, Robbie. Getting that return on investments is difficult. So, all right. So hopefully the people that need to get into this lab got into this lab. If you haven't caught up yet, that's okay. It's not like you have to follow step by step with me kind of thing. I'm just going to try to show this in this lab environment and get you guys up to speed on these labs. Again, you guys will have 30 days access. I'm just going to kind of follow through here. For those of you that haven't used this NDG Online format, the goal here is that you'll end up seeing our topology for each lab. In this case, we just have the one virtual machine that we're going to be interacting with, which is acting as a PLC system. If you click on the content, this is kind of some new HTML5 style content. In the old days, it used to be kind of a PDF style, but it's going to walk you through all the steps to how to do this. It's very prescriptive, and so you can kind of walk your way through there. And then this PLC tab here is going to take you straight to the VM. So for the ability for you guys to see everything, I'm going to go ahead and undock this virtual machine, which will let me eventually get to a side-by-side type setup here. There we go. And so hopefully everybody can see my screen okay. Is that too small?
Yep.
Okay, great. I'm going to try to resize that a little bit here so you guys can see it. All right, so one of the things in these lab settings is it's going to always give you the passwords and the things to get on. Yeah, you got it, right? So unfortunately, that's part of it, but it does get more secure as we go along. All right, so to get logged in, password is password. That should get you out here to this little PLC system out here. All right. Now, a lot of this lab is very much on the written side, so it's not one that you're going to be doing a lot of programming and things right off the bat, but they do give some great descriptions of the PLCs and the things like that I talked about before. So they worked really hard on getting the background concepts, and the goal behind this lab set is that you don't have to purchase a book. So all the material, the information that they need to know is always going to be in the labs. And then as they go in to step in to do some of this, you're going to get some background. So think of it kind of as a digital online book as they're moving through. They're going to give you some history on the PLC controllers. What's a relay? What do relays do? And connect the two circuits, etc. So this is really good information for you to read if you're trying to figure out what PLCs are in the OT space. I'm not going to take you through this because we kind of covered a little bit of it, but they do a really good job of describing this out. These symbols are going to be kind of important. So as you're looking through some of these diagrams, this is a normally open type symbol. Normally open is going to be like a push button or a push switch where when you push the button in, it makes contact and then it actually lets the signal go through, right? A normally closed is where it's always closed and we're wanting to break that connection. So a good example of a normally closed, some of you may have these at your schools. It's the badge access into a door. All right. So if you want to get into a door, those systems are set up on normally closed. You badge in, that triggers a relay, which moves the little actuator inside the door and allows you to pull the door open, or releases a magnet, interrupts the flow, etc. That's normally closed. Fails secure for those of you that are in the door side of things. So how many labs should we complete each day? JB, I'll be honest, we're going to try to get through as many of these labs in the first 2 days was the original plan. That's going pretty quickly through these as we go through, so I'm going to kind of demo them. And that was because Wednesday, Thursday, up into Friday was really kind of focused on the CTF side, but I'm really focused on you guys as attendees. So if you want to go more through these, or you want other labs that help assist students with these, which I have a whole slew of those as well, I can give you access to any of that along the way. So again, I like to shape the workshop to the people that are in it, not dictate what you came here to learn, if that makes sense. So yeah, you're going to see a bunch of these different signals and things when we go to do some ladder diagrams and some drawings and things like that. But this is kind of a good idea of what that architecture will be. And so within our lab environment, what we're going to do is take a look at a piece of software called OpenPLC. And this is something that a student can run and learn PLC programming. It emulates an exact PLC. As a matter of fact, you can make it emulate different kinds and brands of PLCs. So it's really, really great to work through as we go through. So we have this OpenPLC editor over here on the left. We'll get this launched up. And this was actually written by a PhD student that was trying to do this for his dissertation. And it turned out to be a fantastic project as it goes through there. It doesn't get updated as much as it could be, but it's really nice for teaching these basic concepts to students. You can kind of think of it almost like Packet Tracer in a way, where you can drag and drop and build the code and do all the stuff in here, and then you run it in their PLC runtime, and all of a sudden this Linux virtual machine, in this case, acts like a PLC. So when you ping it, when you test it, everything else, it acts like a full-blown PLC. So we're going to go to File and Open. And inside of there, we have all these different programming language examples in here, right? So the first one we're going to play with is that ladder diagram. And then at that point, we can click on Open up here. And you're going to see some very basic code over here on the left-hand side with your motor controls, your reservoir, how that comes up. In this case, we want to focus on this res over here. So if we click on that, and then you have this motor control instance over here on the left, and you can see the little edit symbol there, which I double-clicked. Didn't mean to double-click. There we go. There's the edit. And so we can see these Boolean values out here in the middle. Now, I am going to try to resize this if it allows me so that we can see this a little easier. Let's see, displays. See if I can resize this. And it's going to fight me on the automatic resizing. So let's do actual size. There we go. Okay, that's a little easier. So now you can see this a little better. So inside of here, you're going to see some simple diagrams like we showed you at the beginning, where we have it currently with a stop button. We have our start process as we go through there, and then the motor output. And this allows us to send that signal through there in a ladder type diagram. Swap between these here. Whoops, wrong one. Grab this other one here. Back content. I apologize for flipping back and forth here, but make sure we follow along. Okay, so as we go through there, we're going to be looking at the symbol that goes in. We'll see that little edit symbol, and that's what you see up here. And if we do our toggle full screen, we'll be able to see this all the way out. It's kind of important in that lab environment to be able to see and adjust things that are through there. Full screen, keep this out. All right, so what we want to do is kind of drag and expand this to say, which we can see there pretty easily. And this design is using basic ladder logic. It's the majority of the PLCs that are in their use today. This language is going to mimic kind of ladder diagrams that electrical technicians will use when installing kind of relay circuits, and you'll run into ladder logic as a typical PLC language throughout this particular lab set. So this is just getting you familiar with this environment, being able to poke around and play in here because you are going to kind of build some out yourself. It's a very, very simple lab to get started in there. That's actually the end of that lab. It's just meant to get you introduced into the environment. What's nice about these kind of lab styles, and this is really getting into the CTF side, is you could add your own example into that virtual machine if you are self-hosting this. And so what that would allow you to do is have an example of a diagram, and they either have to fix it as a capture the flag, and then if it does something, you can have it capture the flag. We'll talk about that on Wednesday. But there's multiple of those kind of things that we can bury into these virtual machines for them to run. Or they have to go search out a file on this PLC system and then inject that in there as well. The capture the flag side isn't necessarily just for capturing the flag. In the early days when I used to build capture the flags, it was for grading. So I would use them as skills-based assessments. Those of you that are familiar with the Cisco realm and SBAs, I used to do those kind of things all the time. And so I use capture the flags as kind of a skills-based assessment at the end of most of my courses, where they have to go through and complete that capture the flag. And then if they get the different flags, they get all the points that are included in there. And it's all based off concepts that they learned along the way. That was the goal here within this critical infrastructure, is maybe we could build an SBA of sorts so that you have a great way to have a kind of final exam in this course, and build a capture the flag, which is always more fun for the students as well. All right. So with that one done, we can go ahead and end that reservation. Now, again, that's a pretty simple one. There's going to be more detail in some of these other labs. So you can end that reservation and then jump into lab 2, and we'll cover this one, at least get you started in this one, and then we'll go out to lunch. And for those that aren't familiar with the NetLab Plus side of the system, you basically buy the hardware license, which gets you the ability to do, or in this case, a virtual license now that allows you to have multiple of these pods. So for example, this pod that I just introduced here could be a series of multiple VMs. There could be one VM like in this lab, or there could be 8 VMs in some labs, etc. But you have access to this pod. And so given a Durin lab reservation, like I'm doing here, you could have up to 16 or 32, 64, etc., depending on the licensing you purchase, for your students to be able to access. But the cool part is you can take the content that comes from NDG, and all the content inside of there is free at that point when you purchase for the system, as long as you're a part of the different academies. So labs like this are available to free if you already have the platform. The labs are automatically free inside of there. But then you can take those labs that are free, for example, this lab set, and build your own custom labs on top of it, which is kind of what I'm looking at doing here for the capture the flag side. So I can take all the great content that NDG developed for this and then be able to build additional, challenge labs for my students, so that I don't have to go build out a brand new lab set. I have something already built for me that I can start with and then kind of expand from there. Yeah, Terry, that was really the main goal. This was kind of a new concept about 2 years ago when we were building in this one, was that you would not need a book. So critical infrastructure, if you can imagine, the cost of the hardware, things are so expensive to get into that schools just wouldn't adopt it. And us having been around the Cisco Academy for about 25 years, 6 years more, we know what it's like when you have to have equipment cost, and that the adoption rates start to die down. So the whole goal was to get this lab set where there was no cost barrier for equipment, and that you could run this on existing stuff, but really have that standalone where you weren't required to have a $150 textbook to teach these, if you could find one. That was our biggest struggle when we were writing some of this, was there wasn't a whole lot of textbooks to go off of. But if you're interested in the background on how this lab set was built and the concepts and things that we worked with, it was a good group of people. There was about 5 of us that really consulted together to put it there. I'd be happy to show you some of that as to who was all involved. And it was a bunch of different technical training areas that really focus on OT and training OT. All right, so we'll come back in here with the same password that we had before. Let me break out this content here. And I'm going to end up keeping this content on a second screen here. I'll just kind of follow through on the main one. Again, the main thing with this one here is it's going to start off with an introduction of what this lab is, those standards, which are the different programming languages. So in this case, you're going to get a little more hands-on with which programming languages are available in this system. And again, this OpenPLC system allows you to deal with almost all of them that you would typically be out there. So it's really kind of slick on how that works. But they're going to take you through some examples of what that looks like. So the first one we're going to pull up with is going to be that ladder language. So let's go ahead and get OpenPLC back up. I'll expand this out here so we can see. And we'll go to File and Open. Again, with that ladder diagram that we talked about before. You can kind of bring that in there. You're going to see that tag list. So you have this instance 0. We click on this edit. This is referred to as this tag list. And these are all the tags in the program that are local to this routine. So we can tweak whether these are Boolean values or a bunch of other stuff, which you guys will play with as we go along there. This is also going to be important when we set up these Boolean types, when we interact with our SCADA system. So our SCADA system, which is kind of a dashboard, really needs to know from the PLC, is this a Boolean value? Is this a, what's the initial value? Does this go from range 1 to 10? Is this going to be emulating an analog input? That kind of thing. So that's really what this is all talking about here in the center of this screen. We also want to take a look at a function diagram. So let's look at open and function block. And again, we can click on this side here. We see that we have very similar outputs. And if we look at that res, you're going to see this here. Now, function block looks a little bit different down on this section. Again, I'm going to change my output here so you guys can see. Try to go too big. Let's do that again. There we go. And so you can see that this here is what's called function block diagrams. And so you have your start process. It's like a big flow chart. It's going to come into the input on this and then you will check other inputs if it's not an in out, and then it comes on the outside moving in. And this is the motor latch, which is really just a big relay as you're going through there, turning that on and off to turn that motor off and on. So there's a little bit of a difference between these two diagrams. Again, different vendors use different programming languages to decide which one you're going to be using. So we'll go to open. You got it, Terry. So in this case, it's really the same program. You're just seeing all the different languages and how you would write that same program, which is, again, important as you're working with different vendors to see how you would program that. So on this structured text, we can come through here and edit it, and it's going to look more like this: motor in, motor out, starter, stop, that kind of thing. So it's a different way of doing the same program but they're doing it in one line of code versus a drag and drop ladder diagram kind of thing. All right, then we also have instruction. So with that one, we'll click here and edit that one. And you can see, again, it's very similar in the way it's laid out, but a little bit different style. So you're coming in here with local variables of your start, your motor output, and or stop. Again, same program, just different way of understanding how it works. Right. Next one there will be the sequential flow chart or function chart, sorry. And this one again seems to make a little more sense as you go do. So it's like a big flow chart. As you can see, it's stepping down and doing the same thing. But you'll notice this one requires a few more variables up here at the top. Having a starting sequence, a running sequence, stopping sequence, things like that. So there's other functions that have to be built in on some of these other ladder or block diagram type programming languages. All right. So hopefully this gives you a nice little visual representation of what each one of these are. Again, these first couple labs are really meant to be introductory. And what's great, the way these labs were written was that the first 6 labs could be used all on their own just to teach PLC concepts. All right. You wouldn't have to use the other half. The other half is useful for those that are in IT that want to teach IT and OT concepts and why we have to secure them differently. And we have to be very careful as IT admins on how we do OT operations. So labs 7 through 14 are really focused on the IT type of group. So even the first 6 could be totally used on their own. They have all this background information in the beginning, as you're seeing, along with really detailed descriptions as you're kind of working through that. After about lab 7, that introductory starts to fade a little bit, in that we give you a precursor of what the lab is, but it's not really meant to be a textbook in that regard. Anybody have any kind of questions or comments on these first couple labs? Great. So I think we'll pause here and we'll kind of pick up the other 4 here after we get back from lunch. There'll be some more that I would like to expand on, and I would really like to get everybody feedback on what this type of stuff is. Wish you could download content into a PDF to view the instructions. Yeah, so in the old days, it used to be PDF, Terry, and we kind of went to this style here. And the reason is we can update it so much faster. In the old PDF style, it was kind of broken and a little rough to be able to do that. It took forever to get updates and things pushed out there. So people were doing labs that were broken or wrong. This new style is quite a bit easier for that realm. There are options if you have it. You could also do PDFs in there as well. Yeah, so yeah, so it is quite a bit different. What you're talking about there, JB, in terms of check marking and moving things through, that's really some of the new features in the enhanced content. So those of you that have been around the product for a while, this is referring to their new enhanced content. And what's nice about this is because this has integration in with LTI and being able to integrate within your LMS, your Blackboard, Moodle, that kind of thing, is that we can bake questions right into this. And so a student would have to answer a question as they go through here. And at the end, it would auto grade all of those and send that grade into the LMS. So instead of you having to come up with a way to grade labs, if you guys have been around there, the new enhanced content allows you to actually do little mini quizzes or kind of like little capture the flag type stuff that we've looked at in the past, baked right into the enhanced content. So. Enhanced equals old school. Yeah, yeah. All right. So like I said, we'll break for lunch here. It looks like we're doing lunch from about 12 to 1. And then from 12 to 1, we'll come back about the 1 o'clock mark. And it looks like we're going from 1 to 5:30 Central Time with about a 3 o'clock break. So I will pause the recording here. And I went ahead and started the recording. So for those that missed that first part, I forgot. Okay. So in this, in order to get started here, we launched our PLC controller, or I'm sorry, our OpenPLC software. We're going to go ahead and go to File, New. And in this, we're going to go ahead and click this plus button over here, and we'll need to create a tank fill. Now, we need to do this inside of our normal home directory. So we'll go over here to our home directory, and then we'll go ahead and hit this and type in tank fill. And hit create, and we'll go ahead and open up this folder. No problem, Gordon. Let me get you marked off there so I don't lose you. I think I still had you marked off. Great. Okay. Let's see, while I'm here, Rodney, are you back? Assume that's the case. Let's see, Terry's not here. Fred, still not here. And David is not back yet. All right. Okay, so to get this filled in, the first thing we want to do is throw in our tank fill. This is just the name of our program as we go through there. We'll set our language for LD, or ladder diagram, and go ahead and hit OK. Go ahead and go to full screen just so we can see the most out of the whole program. And then from within here, we need to do some adjustments and expand this pane. It's usually this pane over here that needs to be kind of opened up so we can pull some stuff down. So we're going to click on this tank fill, and we need to click on this plus sign up here. And that gives us our first local variable that we can use to adjust. Now we have local var, we have our class of local. We need to set our type, and notice this is a DINT. That is referred to as a digital integer, and we're going to want to change this out to either a Boolean or a real data type, depending on what we're using at the time. So the first thing we want to build out here is a variable called eStop, CMD, and that class will be local, and our type here is going to be set to Boolean. And this will be our emergency stop button, our emergency stop command. As we said before, one of the big things, yeah, I got you here, Terry, you're good. One of the big things in OT is safety. And so this is that big red button that people slap on the control panel to make sure if something's going wrong, that we can shut down the system immediately. Next one we're going to create is our tank valve open. And this will be our outbound variable for our output. And we have a local variable there, and we need our tank value, whoops, open output. We have another variable for our tank level high, and this is going to be our high alarm. So tank level high alarm. And this will get triggered whenever our tank reaches our high section. We would obviously want a low alarm there too. So let's set a low alarm. Then we have an auto fill command. This is going to end up being a routine that will automatically fill it to a certain level and then stop based off the levels that we set earlier. So tank fill auto. Then we need to go ahead and set our tank level. This will be read in as we go through here. So this will be our tank fill or tank level. LIT. Let's refer to our tank level. We need to set our fill point for this tank. So tank full SP. And this will have an initial value of 8. And what that means is when our tank reaches 8 on a scale of 1 to 10, then we go ahead and shut off the tank. That way we don't have a chance of overfilling it. So tank full. And we'll need our tank empty. And then obviously we don't want the tank to actually go bone dry, or that would stop things. So we're going to wait for it to get down to a 2 level, and that will indicate it's empty. And then at that point, it will trigger that tank autofill command. So this is our tank is empty. Set point. And then in order to trigger these alarms that we have up here, remember these are Booleans. And so these down here will also need to be reals. So instead of Boolean, we want these to be real. These are going to be real numbers. This one is also real. And this tank level is an actual number that'll get read in. And so we need to set what is going to be low for us and what is going to be high for us. And that way we have a way to trigger those alarms as it comes through. So I'm going to minus that one out. Go back down here. There we go. We're going to set this to 1.5, which means it's dropped below our threshold. And then obviously we want a high alarm as well. And this will be 8.5. Okay. So it looks like we've got all those in there. Pretty easy to get these all filled in. Again, the idea here is that we don't set an initial value for the LIT. This is what's getting read in from a sensor or wherever it's currently at. And these tank full set points are going to tell us when we are triggering some of these alarms that's up here at the top. All right, so we're going to actually build those. We got to drag this little section up here. This section down here is where we're actually going to build our ladder diagram. So to get started, we have to have a power rail, and this is going to get us initially sending that on. So we'll right click, go to add, and add a power rail. And you'll need one left rail, and you'll need a right rail as well. And the horizontal lines on these are called rungs, just like a typical ladder. And that's what will be created as we go through. So we'll add a left. And we want to have 10 pins on there. And hit OK. And then we'll add a right, along with 10 as well. Again, you can see how we can adjust these and move them around and get our diagram just the way we want it. So I'm going to move this up here just so we can kind of see what our ladder looks like. So the first rung that we're going to build out is for the open tank valve, and this will happen when the tank autofill command is turned on and that tank level alarm is off. So we want to make sure it's all set up there. We'll set up. We're actually going to bring these out a little further away from each other so that we can build all of our logic in between. All right. So the first thing we need is a contactor. So we're going to add contact. And this is going to be a normal contact that comes in. It's going to represent a Boolean value of either on or off. And contacts can either be set to normal, negated, rising edge, falling edge, that kind of thing. Gives them a little bit of variance as they go through there. So in our case, we want to go normal, and we're going to pick our variable of tank fill auto command. And then hit OK. We can see our little command out here for that variable. And then we'll want to add a negated version of that. In other words, we want to make sure that our alarm is not on. So add contact negated. And we want our high level alarm. Again, this means when this is ran and when this is not active. We'll need to add a coil. We can see here for this coil is going to be our tank valve out. So we want to right click on this open space. We'll add it in there. And then this will be a normal one with the variable of tank fill out. Tank open out, sorry. And then we need to kind of connect everything as we go through there. So contacts will need to be kind of connected on the power rail. So we'll want to set up something that looks like this with our tank fill and then our open valve out. Okay. And so we'll need to connect these rungs. If we simply click on this little one here, connect it out, go this way here. Build out our ladder. Obviously, I should move that up a little bit, and we'll move this up a little bit. There we go. And so you can see as a programmer, you don't have, if you can visually see how you're going to work with this, ladder diagram may be easier. Obviously, there's other ones. We showed all the structured text and stuff, which was a little more minimalistic. But it all depends on what kind of program you're building and the hardware that you're using inside of that. So we'll need to use a concept called variable expressions. And for example, we want to have an output that energizes when a level gets to a certain point. And so we would create a simple variable expression to accomplish that. In this case, we need to create a tank level is less than our valve open set point, meaning we have these set points over here, right? And so we want this to be open as long as it's below 8, for example, on the full side. And so this means the tank level is below the set point, and we should be good. So for our rung 2 logic, we'll click on add and variable. And this will be an input variable. And in this expression field, we want our tank level, LIT, to be less than or equal to our tank empty set point. And okay. Right? We'll also need to add a coil over here to bring back our command that we had. And we'll set this for a variable of our command. Hit OK. And then, of course, our rung is going to look something like this here. Bring this up a little bit. Come on, mouse. There we go. Adjust it there. Okay. On our third rung, we'll need to remove that latch from the set coil when the tank is greater than the equal set point or the emergency stop button is pressed so that we can stop the tank immediately, or even when the tank high value alarm is set to true. If any of those are correct, we'll go ahead and shut off our fill valve. So we'll start with adding a variable. And this expression is going to be our tank level, LIT, is greater than or equal to our tank full. Then we need to add another contact using our e-stop command. And also we'll need one for our tank level high alarm. Okay. Create a reset. You can kind of give this a little bit of space here. Go. So we'll add a coil up. And then these values, we'll want to set up a reset for our command. That will do is reset that tank auto fill subroutine to make sure that it turns it off. We're going to set that over here on this tank fill auto. And we'll go ahead and crank that one over here to the side. This one is going to have a connection as to this set point. If I can keep it there. We'll also have one coming from here down to our e-stop command. And one coming down to our high alarm. Okay. Now you can make it nice and pretty like they show you in the lab there, would have some issues and whatnot. See, is the latency with the app or with the VM host in the app? It's more of the part that's being there. This is still probably running on the ESXi infrastructure. When it gets to Proxmox, it's a little bit better actually with the new backend side. All right. So rung 6 here. This is going to be setting up our alarm. So we'll have a new variable. And just like before, this one is going to be focused on our tank level. LIT greater than or equal to our tank level, our tank high alarm. Set point. Okay. Room 7 over here. This would be for our tank level lit. Be less than or equal to our tank level low set point. Okay. Coil for that guy. Along with the ladder. And now I remember I was supposed to skip those two up there. So we're just going to bring this set point to go from here, here. That one can go away. This guy down. There we go. Of course, obviously, again, I could clean that up, make it nice and neat. That'll work. And so now, if everything's set up correctly, we should be able to click on this little running man up here at the top, and that will start our PLC simulation. What that does is allow us to interact and make sure that our program is set up correctly. And so if we look down here at the bottom, as long as everything compiled and we don't have any issues, we should be okay. And once that creates a runtime instance, we should be able to see this over here on the left of all of our different pieces. We click on these glasses up here, we can see where it's currently at in the program and where it's moving to anyway. And you can see where we would have a fill valve on or a fill valve closed depending on where it's going. So the default value for the tank level is set to 0, so the tank level should be open. So this auto command should be filling up right now, and it's not currently up. I probably have it set up incorrectly. Debugger pane will allow you to adjust those. Kind of go through there. So in my case, I don't have the correct data type set up like I should be. Let's pull this down here a little bit, make sure I didn't mess something up. There we go. Yeah. I'm sure I didn't connect something that I was supposed to connect. So let me go back here and make sure. This is a good patience for your students to figure out what they should have had and not had at the same time, right? So let's make sure I got these all right. That one looks correct. Autofill. Somebody sees my bad section here, feel free to yell it out. Aha. Should not be alarm 0. That's part of it. It's the alarm. Cheat sheet, the PowerPoint, yeah. Will we be expected to build a ladder on the exam? No. No, but what I will be interested in the exam, like on this part, is the concept of a Boolean versus a real, maybe something that might be on the exam. That's kind of the gist of it, kind of thing. Let me double check, make sure I didn't make any other errors here. Actually, it looks good. Let's try running this again. Let's see here. Tank SP. Yeah, I see the range over there. We're not quite there yet. So if we click on tank, this instance, actually, those are all different ones, right? So let's see here. Tank autofill commands, level lit, full. And so what we need to do is change our current tank level. Should be able to edit. Try this again here. You can tell it's been a day or two since I've done this one here. So tank valve open. So let's add the right one in here. Tank level lit and the tank empty. There we go. The goal here is to kind of set and force a variable. So we should be able to override those. Why am I not able to set those? Apologize. I'm trying to figure out which piece I missed here. All right, e-stop, local, boom, real should be level lit. SV empty. Okay. I'm working on it, Wendy. I don't know how many times I've done this, had no problem. So I clicked on something wrong here. So let me figure out where I messed up. Think about. No, sorry, JB. I'm doing the bad thing and being silent as I'm trying to figure out where I made my mistake. So that's on me. I'm trying to go through here and see what somewhere here I did a typo and I'm trying to figure out where my typo's at. Nope, you're good. I tend to fill dead air with my voice, but then I'll put everybody to sleep by the afternoons. Let's see, alarm. Tank level high. Well, I'll be honest, that looks like it's supposed to look. So try this again here. Yeah, I hear you. It's actually usually pretty straightforward. Not sure what I clicked here, to be honest. Let's do that. Stop. Okay. Let's see here. Tank fill. Where'd you happen to have a typo at, Wendy? Just to see if maybe I have one too.
I just looked at yours and no, it wasn't in the same place, unfortunately. I think I had an extra L in alarm or I'm sorry, I missed the SP under tank low alarm.
Oh,
I
okay.
missed the underscore SP. So I fixed that and it ran, which is fine, but now it's like locked up.
And normally it looks like these real numbers should be there.
And I just looked at yours compared to mine and it looks the same. Unless I missed something.
Play with this here. Good news is we have an answer key. We can go load it here in a second. Oh, still didn't like those values. All right, well, we're going to cheat and pull the answer key. Somebody have something they saw on mine?
No, I was just adding that I yelled at the computer and whined a little bit, and I went on to the next exercise. But I can't wait to see the answer. Go ahead.
All right, so to find the answer here, the good news is we can go to open, and we can go ahead and save our project so we can figure out what I was missing here. And if you go to this tank fill inside PLC, that's ours here. What we want to do is go into, if I recall, it's documents, languages, and tank fill. And so this is our project, or what should have been the output of our project. Whoops, let's go to res, edit. Let's see if I missed anything. So that looks right. That looks good. Same section. 8215. That looks good. Let's run that one. And of course, that seems like it's working, right? So we can look at the glasses, and so we can see what's happening here. It's go ahead and triggers the tank till it fills. At some point, it's going to change that value of the current level, which is here. And then once we get to that current level, it would change it. So if we followed along with what we saw in our lab, if we click on our tank valve open glass, our level glass, and our empty set point, and we adjust our tank level here to say 8.2. We'll see that auto command fill shut off, and that you can see our current one is going to fill that because it's above, our high alarm should be triggered at that point as well. Setting that up above our empty one there. And so that triggers this auto command to immediately shut off when it gets above that. Good news is while this looks like it's something, this is a little on the trickier side, we'll actually be able to use this in a runtime that makes this look a whole lot easier and works and operates a whole lot easier. Okay, so let's end that reservation because that will get us into something where we can actually play with a good one. And that gets us into the SCADA and supervisory thing. So again, as a overview of SCADA, that's your supervisory control and data acquisition. Might be a terminology you need to know. This is where we collect all that kind of information that's coming off those PLC controllers, etc., and it will consume it as almost like a dashboard, but you will eventually pass that off usually to an HMI. And that HMI is just something that's easy for humans to interface with. So a lot of times that can be like a physical control panel, or it could be a digital display of some sort. That's usually what it is in newer factories. So whether it's a touch screen or a big red button, things like that, that's what you're going to use. So the idea here in this lab is that we're now going to take your PLC controller, the one that we just were playing with earlier. And now that we have a particular logic loaded up on it, we are going to connect it up to our SCADA system inside here. Let's look a little bit at this lab, get you some information. And so again, SCADA is going to come through there. It's a control system made up of physical hardware and some software components that provides our remote access to the end world. This would be something that is common in large distributed industries like oil, gas pipeline, electrical grids, water treatment, distribution, transportation systems, etc. Those are all based off SCADA systems. So it's meant to be a centralized application of servers that gather information from the field like PLCs or RTUs, and then displays that coming up there. And it typically interfaces with that HMI, like I was saying before, for alarming. So here's a good idea of what that is. Again, you have all your sensors and stuff out here on the physical network. Those are interacting with the automation control stuff. So whether it's an RTU or a PLC, those are communicating back to an MTU unit or a place that collects that data and then passes that on up to a full-blown SCADA system. So you're going to see all those different communication protocols at this level, and then feeding that back up to a SCADA system that runs up here on supervisory control. That HMI is what is going to look something like this, and you'll be familiar with this by the end of the lab set. And the idea here is it gives you a visual representation of what's going on. So if we go back and think about our tank fill program that we just wrote, this is our little valve over here on the right. It's either going to turn on the water or turn off the water, and it's going to fill it up through this tank. And this is going to give us our current level indication of what level that tank is at. Remember, it would fill up to about 8. It would drain down to about 2. And then once it hits 2, the auto fill valve will turn on, which is this one down here, and start filling it back up and then turning it back down. All right, so we can set up alarms, we can set up event recording, data historization, so we can kind of see what's going out there. There's multiple different SCADA systems, and there's several free open source ones that are out there. In this lab environment, we used basically one of the newest ones out there called FUXA. And FUXA is kind of a web-based software. And what was nice is it was very easy to use for students. The other one was a little cumbersome. As a matter of fact, I could literally crash it really easy by overloading it with certain systems. But in this case, we're going to use this one here, which is kind of a newer, more fancier version of that. Obviously, most vendors have their own version of a SCADA control system, but this is the one we're going to play with. So we'll get logged in here with the super secret password. Let's see, is this something that needs downloading in Kali Linux? Does it come with it? It doesn't come with it in Kali, but you can definitely download these software packages locally. All we are doing is, like I said, FUXA is this software here. Yep. Slapjack. Not the same thing. Something else is stealing that one. Let's see here. This is it. So this is a GitHub representation, and you can see you can build out some really big SCADA HMI dashboards, and they can look pretty cool. And this is what it would look like of an industrial setting. This might be up on a giant big screen somewhere so that you can see all the parts that are happening through the system. And it's a pretty cool little interface. If you take enough time to build everything out, it works with a lot of different protocols, a lot of different backend. It's all based on Node.js and HTML5. So like I said, it's kind of the latest and greatest one that a lot of people like to use. And we'll be using that to kind of build out our nice, fancy little HMI for ourselves. There's another one out there that I think it was called SCADA BR. I believe that's what it was called. Yeah. And so SCADA BR was a pretty popular one that's been out there for a while. It's based off of a Java Tomcat type server. So frankly, it's very vulnerable because I was able to write some pretty gnarly things to take it down pretty easily. And again, that's kind of where we ventured off into this FUXA one. So, okay. Sorry, little background on how these labs are written, but both are great to introduce in the classroom. It's all open source. It's all free. As a matter of fact, you could take out the examples that are in here and use those if you have access to the content, etc. So to get loaded up here in SCADA, we're going to go ahead and launch the FUXA app. So sudo FUXA and our super secret password. Great. So we'll launch our Firefox. And up here in the address bar, we'll run on our local app here. And so this is the main app. We want to go to /editor. And that allows us to interact with the inner workings there. And so we want to open a project by clicking on the little save icon. Let me break this back out here so everybody can see it a little easier. There we go. And we'll open a project. And so the first one we want to play with is this tank fill. And again, this is a nice little chart for us to try to work with and interact with. So this is kind of a pre-built example that works with that tank fill program that you guys just wrote before. And it's meant to give a HMI design that prioritizes situational awareness. Typically, this HMI will be grayscale, and the design will show the progress as an easy to understand manner. Information that this operator needs to understand in this process is brought up in the HMI. And in order to show the process, we need to revisit some of the items back in OpenPLC so they can get those numbers and connect our PLC software to connect with this actual HMI. So to get that to work, we're going to go ahead and go to our connections. It's over here in the setup cog. There's our connections. And we can see this OpenPLC controller down here. And we're going to click on the edit. And we need to point that over to our PLC VM. So that's at the 192.168.1.10. And it runs on 502, which is Modbus TCP. And then from there, now that it's listening, you'll notice there's still no connection over here on the right. We actually have to turn on our OpenPLC system. So we'll go out there. Can I summary Modbus? Modbus is basically just an old school communication protocol that's written for this low level communication. Typically was written for serial side, and now you can do Modbus over TCP as well. Basically, you're sending a series of inputs that are coming across the wire over a standard open source style protocol. So you can send ones and zeros. You can send different levels. As a matter of fact, we're going to do a Wireshark on that, Terry, and that really gives a much better understanding on there, because you can see how those bits or how that communicates across. And then we actually do some hacking on that so that we could tear that apart. So, yeah. All right. Super secret password. And we'll open up Firefox on this system. Now, we're not going to use the editor. The editor is what we would use to write a program, right? In our case, we've already compiled a program down. We just need to run it so that this computer acts like a full-blown PLC. Before, we were using the debugger and options there. This little OpenVLC web server will take in a compiled program that we create in the editor and then make it act as a PLC at runtime. So we'll come in here, easy login, OpenPLC, OpenPLC. Let's not save that. And so in this system, we'll click on programs on the left. Let me go ahead and pop this one out so I can do that as well here. Great. And so by default, you get this one. We want to actually load it up. So we'll go to Browse. And we have our tank fill sim directory, which is what we want. go ahead and click on this ST file. And we'll upload our program. We'll need to give it some nice names, so let's do that. So tank fill sim. Scroll down here and click on upload program. And if all goes well, you'll see all these variables, and we're going to talk about all these different variables and these data address sections that we're going to be pulling these variables from here in just a minute. So we'll go to dashboard. And down here on the lower left, we can click on Start PLC. And we'll see what this program does is it will start up communicating on Modbus. We can also communicate over DNP3, which is another protocol for another vendor out there. And we can also use ENIP, which is Ethernet over IP. We're also listening on those ports as well. So this is acting like a PLC controller that has the capability of acting like other vendors. And later on, we're going to tell it to act like different kind of vendors all the way through here. So if everything goes well, we should get this running status. Sometimes you won't see that on this screen. You'll just need to click on the refresh button up here or the stop and refresh, and you'll see running up here at the top, and everything down here in the log is just fine. Great. You'll see that we got a client accepted, and from that client, at that point, we can go back to our SCADA VM. Which is over here somewhere. I lost it. Let's try this again. SCADA doc. And we'll notice that this little green dot went green as opposed to the red it was before. And if we click on this section and we hit the play icon, we can go ahead and close out of this settings side. Go back to views. Okay. And then we'll click on this launch current view up here at the top. And if we full size this, we can see that our tank is currently running. So right now we hit tank level 2. At that point, the valve kicked on. It's now filling up the water inside of our tank. We can also see our tank fill chart down here. So we can see that it takes a little bit to fill this guy up. And then if you remember, our set point was 8. And so this should fill up the tank all the way to 8. And there's 8. You'll notice the valve immediately shut off. And so the tank will slowly start draining back out as it's going through its factory process. So we'll notice it keeps going. Now we're down to 7, 6, and all the way down to 2, at which point our auto tank fill command will engage and we can go ahead and fill this tank back up. So real simple program, but you can see as a user in the industry or whatever is over there that having this SCADA HMI type system is much easier for us to see what's going on. All right, do you guys all feel like PLC programmers now? Sure. All right, thanks for playing along, Rafat. I appreciate that. There's a lot to it, right? It's not something us folks familiar with the IT side of the world. There's lots of moving parts, right? And going through there. So this is where it's kind of interesting. You'll get the OT side. You can kind of see what they're doing at the water treatment plant or what they're doing at the power distribution plant. That they have really fancy screens like what you see here, right? So obviously there is a lot more moving parts going on here than what is going on in our simple little diagram. So if we look at this, we can see things like temperature actuators going through here, hot and cold systems, being able to send things through. It's pretty awesome way of going about and doing different stuff. If we look at our home, you know, like here, we could see one that's a real simple pump that gets turned on, the compressors that end up running across here. and the different valves and pumps that get turned on going across a certain side. So yeah, you got it. It's really kind of cool to see what they have there. All right. So that's the end of lab 4. The goal is to get you familiar with how to load this up, because you will see how this works. And then that's where us hackers are going to get involved, and we're going to start breaking this thing and seeing just how easy it is to break stuff on this side. And then, of course, if we can take over this tank, right, we could then tell it, oh, no, you're only at tank level 2. Go ahead and run this open valve. And then instead of it ever getting to 8, it just says we're at 2. And so this tank goes on forever. And if it's water, you know, water spills out the top. If it's not water and it's a caustic material like acid, then we're going to have a real bad day as the plant starts filling up with acid and overflowing. So really, really important. Now, obviously, in this little program here, we wouldn't just have a sensor here that says 8. We would have a fail-safe sensor up here that would do a second one going through. And when that comes in, it would go ahead and trip this system here as well. But you got it. Things like water flow for nuclear plants, things like that. It's really important these systems work, right? So I'm going to pause here for a second before we go to the next one. Let me pull up another workshop that I did. Let me see if I can get this right one. So this here was they're basically talking with us, and our goal was to build this man in the middle attack scenario, and we kind of built that out. That's what these labs are all about, where you will end up going through and hacking that PLC in the long term, and we'll basically compromise it. And we can trigger it to do a bunch of different things that are inside of there. And so all those labs that you've seen so far are all written by, again, one of my students that was in there, who was an engineer on going through there. Now, this engineer was for electrical engineer in a power industry, and they talked exactly about how these attacks all come in and cause some pretty bad issues in there as well. Let me see if I've got, there's other slides here for stuff that matters that's relevant to us. So let me pull that up here. So this was one thing I'll give you guys a link to as well, is these CISA training, and you can do this training. And this is, let me just pull that link up here real quick so you guys have access to that. If I didn't close it, I might have closed it. There we go. So this is the training calendar for the National Coordinator of the Critical Infrastructure Security and Resilience side. This is all based off CISA, right? So the Cybersecurity Infrastructure Security Agency. These guys build a lot of training for critical infrastructure and control systems. And so they have these 2 virtual classes that are available, ICS 300 and 401. I encourage you guys to go through those if you guys are planning on teaching OT. These are great hands-on labs that are all based out of the research Idaho Falls labs. So the Idaho National Lab, this is all kind of based out of their INL. And we've worked on a partnership with them because they're using the NetLab product under the hood in order to deliver some of these trainings. They have a bunch of physical gear, and they were trying to figure out how to get this during COVID to continue all these trainings that we're going through. And so they ended up using a NetLab product under the hood in order to deliver some of this training. But this is all free for you guys to sign up and get some of this ICS training going through here. It's really pretty cool to go through. What's cool is they've actually integrated it with real equipment. So if you look over here, like those CISA 301 labs, you're going to connect out to a real PLC controller, some cameras, a real HMI, and be able to see that when you make a reservation in that pod and interact with it. So it's pretty cool for you to be able to interact with. This is what it would look like if you took their on-campus side. So this is like a big data cabinet that they got a bunch of PLC controllers in there. That's what's being snapped in the middle. And you can see that PLC at the top, and then there's sensors and arrays. and how they would get to work with that. So here's like a big industrial control system. And again, you would get to interact with this. This is another demonstration of what an HMI would look like if they run it up here on the screen, along with the rest of the industrial control systems in there. So one other piece I wanted to kind of show here real quick. Let's see. Of course, I'm missing the one attack scenario I wanted to show you guys more than anything else. So let me find that, because that was pretty important throwing through there. Last year's. Yeah, here we go. So in 2021, we had the U.S. Colonial Pipeline. You guys remembered that. The way they attacked through there was doing a VPN account that had been dormant on one of the accounts. It took several days of downtime, causing, acute shortage of our fuel and price back then. That one ended up being a ransomware type thing for $4.4 million. This Tampa area water system poisoning was another big one in 2021. This is where a hacker used remote access to break into the system. The hacker ended up increasing the level of sodium hydroxide in the city's drinking water by a factor of 100. And of course, an alerter or an operator alerted authorities after seeing a cursor move on the screen. And it was just old school remote desktop access that they had left open, that a hacker was able to take over. Obviously, that can cause some pretty serious issues, more than just what we're demonstrating in the lab here. So those were all good labs. There was one other thing I wanted to kind of demonstrate here. Okay, that was all from last year. All right. So sorry to go off on that little side note, but that's really what's nice to tell the students, because we're all IT background, right? And so what is the one OT attack that we always talk about? I'm sure somebody in here knows exactly what I'm talking about. There's one big one that we talk about when it comes to OT, critical infrastructure, and why you got to protect stuff. It's a pretty famous attack that happened. Not a DDoS, wasn't a code red. Yeah, it's the one attack that we talk about almost all the time in IT. Give a hint of a nuclear plant. Stuxnet. There you go, Carl. So Stuxnet is the main one that we always give as a demonstration of things can go wrong in the IT world. And if you know much about Stuxnet, that was really kind of an offline version of it, right? It was a USB type scenario, not necessarily hacking their way through there. But it comes back to government systems and being able to connect off different networks that go through there. And so what we're going to do a little bit in these labs is, you saw the topology there, and it all runs through a firewall, but the firewall has certain rules open or rules that are not open, and they block. But at the same time, at some point, those engineer workstations need to get out to the internet so they can pull manuals, so that they could do, whatever their email, whatever training is. And if you don't keep completely segregated networks, physically separated, then there's always that chance that those two could overlap. And that's really what this lab set's about, is we're able to break our way in through the engineer's workstation. And then from there, we can do a very similar attack to the Florida treatment plant, where we end up remoting into that machine, and then we reflect services so that we can use some pretty cool attack vectors in order to break in on that side. So yeah, Stuxnet was a pretty common one that you'll see out there when we talk on the IT side. But a lot of these other ones, like the water treatment plant and stuff like that, it's exactly what these guys are all after, and why OT and critical infrastructure is such a hot topic now. And like I said, those were recent attacks, right? That was just in 2021. They're all over the place and happen every day. So I'm going to end this lab 4 here, and we'll go ahead and fire up lab 5. And so in Lab 5, what we're going to be focusing on is back into FUXA. We loaded this pre-built project, right? And so what we're wanting to do is now kind of build that little HMI and how you would go about doing that. So I'd like to go through that lab a little bit. How are you guys liking the labs? Do you see where you could potentially use those in the classroom? Is it kind of fulfilling what you were looking to get for the OT side of things in this particular workshop? And again, it's okay if not. I want to know, right? So
yes, absolutely. Absolutely.
Okay, great. And like I said, so this lab access that you guys are getting, you guys will have this for at least 30 days. Yeah, and if you have a NetLab system, Rafat, you can definitely import this in, especially when it gets to the Proxmox side of the house. Right now, all those labs are being transitioned over to Proxmox, but they're definitely available there. And I would highly encourage you to go through the training out here at CISA because they do a really good job. There's some pretty cool labs that go through there. Especially this 401 evaluation stuff and this 300 course. Those are really easy to go through. There's tons of material in there. And so they encourage you to have students go through those trainings. So if you have like a readings class or something where you want students to go through and do those labs, they highly promote it. They usually do have like a cap as to how many they can have and that kind of thing. But they also have some instructor-led trainings that you can do down here on the in-person side. Whoops, it clicks there. Okay. Break out the new one here. All right, so again, the whole point of this lab is to be building up kind of an HMI. So I'm going to kind of tell you that generally these are screens. And again, they're usually pre-built screens. Some are touch screens. If they're small ones built right onto the machine that's running the process. Those machine-bound ones are generally standalone and just used for simple control or diagnostics, while other HMIs are part of a large control room where they have massive screens, multi-plants going across there. They can uncover huge geographic areas and such, and they're trying to give some centralized support. So initially, an HMI kind of follows this graphic representation of process and instrumentation diagram. Those drawings are used by engineers and are used to build in the industrial control process. Typically, they'll show instrumentation here, for example, like what you'll see here, of how this would go through and monitor. On a really high performance HMI, you're going to see something like this, so you can watch everything going through along with graphs and charts. You would have nice big red, green type thing down below here. Now, like he said, a lot of these are kind of a grayscale or gray background, draws the operator's eye to the part that needs attention. So that's why they have this all set up, and it's done by design. It looks drab, but it's actually meant to show that everything's up and going. In other words, if you see red up here, you've got some problems, right? It's pretty easy to identify. So it's busy, but you can see when things are going bad. And so with situational awareness, this allows us to get a little bit of context as to what you see here. So for this tank level, that would mean the level graphic would include context of the tank fill process. For example, here, where you can see that it should be running between these two red limits. This is your 2 to 8 foot. And that you would have a red line over here for your alarm set. This would be at your 1 and your 9 up here at the top. So if we look at our SCADA machine, I'm going to kind of click through this one and just kind of bring this to a highlight. The goal here is that you're going to end up designing what that tank would look like. So it would come up with a new process there and your properties, and kind of end up getting a nice little grid, and you could drop your tank in here to kind of get that representation. From there, you're going to have some controls. In this case, we're looking for a bar gauge. This gives us that nice little gauge up in the middle. And then we're going to have a valve over here that allows us to trigger that. Again, the way we wrote our software, that's a simple 1 and 0 type thing. It's either on or it's off. We could do this to where we would have an analog one, and that analog one would allow us to turn that valve so that we can control the flow rate. And here they're going to put a little square above it, and that square is just as a line tool. All this does is insinuate that this is an actuated valve that's going through here. We end up drawing a simple little pipe. We can see where that goes up, pipe 1, pipe 2. And then from there, we get this very basic graphic that comes through there. On our PLC side, it's going to have us go ahead and launch that system all over again like we just did in the last lab. Again, I'm just going to kind of click through this section so you guys can see what that tank fill looks like. We'll then connect our HMI up to that little PLC controller that we talked about before. And then from there, you're going to have to end up setting up these different valves and things like that. So things that you would need to know, and I want to pull that up here since we're talking about it, because it's pretty important. So I'm going to launch up our PLC system here. And we'll load up our editor. Programs and upload our tank fill. Now, I mentioned these variable names would be important. So let's go ahead and just upload our dashboard here. We'll start our controller, or start the PLC rather. We can see this is running. If we come over here to monitoring, and I'm going to make this screen a little bigger for us to see. Okay, great. So we can see those values that we originally created in that diagram, right? So we have this tank fill auto command. It's a Boolean valve. It's either true or false. In this case, it's true. Now it just switched to false. So if we look at our tank level versus this here at 8, the reason that switched to false is we had reached our tank level, and therefore we turned off the auto fill command. Once this reaches back down to 2, our tank fill command will go to true, and it will go ahead and hit this valve, which allows it to automatically turn on. And then this would be true for starting to fill that back up. If we look at our other values, we're going to see we have integer values of our tank empty set point of 2, our low alarm of 1, high alarm of 9, and then whether or not those alarms are actually set. So you'll notice here we just have a low alarm, which allows us to go to true if we ever trigger this low level coming down in here. You'll notice that we pull this about every 100 milliseconds. So we're pulling it pretty quickly. We'll notice this is at 3. We're about to see 2 pop up. There's 2. At that point, it triggered our autofill, triggered the valve, and that's what turns on there. So this is important because when we actually work with our SCADA system, that is what we're programming around, is those values as we come in. So let's pull up our SCADA system. And our web. Before we pull up our web, we actually need to launch our FUXA again. So sudo. Nope, not sudo, sudo. Try that again here. Okay. All right, switch to the editor. All right. And so if you remember and what this was showing, we'd do a new project. Give this our tank fill. And if you remember, if we go back through some of those instructions that we saw there, I'm just going to do it real quick so that we can marry this up with what we were doing here. So up here at the top, we'll turn on our grid. This just makes it easier for us to align some of the stuff that we want to put in. And then down here under process engineering, we're going to grab our tank. Ignore that there. Find my tank. Eyes are all wonky today. There's our tank. There we go. Let's blow that up a little bit so we can see our tank. Okay. Again, we'll grab that bar chart that's in there. That's going to be under our controls, which is this one here. And we'll throw that in here for our water tank. That. And then we want to have our nice little fill valve that's under the process engineering down here again. This guy here. So there's a nice little fill valve. We're going to make ours bigger than normal so we can see it. And then under general, we have our nice little square. Again, the square is just in here to kind of insinuate that this is actuator controlled. That little guy there. Perfect. Nice little line. Okay. And then we need our pipe. So down here under controls, we have this pipe that's going to go from here over to our tank. Now we could have the nice little Z thing that they had, but we're just going to keep it nice and straight. We can turn off our grid, and you can see the way we have it set up here. So I'm going to switch back to our tool. So I simplified it a little bit. Instead of having the down and up thing, we can easily add that just as well. To do that, we would just bring that over here, right? Grab this section here as a group, move that back down to here. And then from our pipe, we grab one, we can just move this down. Let's rotate it like that. Shrink it down a little bit. Nope. There we go. Nobody said I was an artist. You could also see just how often they would have to, or how good they would have to be at working with some of those utilities as they're going through there. So we have that up. We got our PLC up and running. It's sending communication off to us. So what we need to do now in our HMI is associate ourselves with those values we were seeing on that PLC side. So we come over here and look at our PLC again. There's a couple of things here. One, these are either Booleans, true or false, right? We also see these are integers, and those integers in this case are whole numbers. You'll then see the location. And so this location is the data address space on the PLC controller as to where you're retrieving this information from. And this kind of gets back to what Terry was asking there as to what this looks like in Modbus, how does this look like in a Wireshark? Well, we actually get to dive into that here shortly. But for now, we just have to figure out what location these are in. And so this is in IW16, this one's in 32, 48, 64, etc., all the way up to 80. And then you'll notice on some of these alarms that they use a totally different location. And we'll talk about what these locations mean here in a little bit. So back on our SCADA side, we can go ahead and make sure our connection's set up. And we're going to call this our OpenPLC connection. Type is going to be Modbus. Again, because there's so much different options that this one interacts with, we could use Ethernet IP or Siemens or all sorts of ones that are available in here. Our polling is going to be set down to 1 second. And our slave port is 192.168.1.10 on 502. 502 being the Modbus port that we're listening on. And then our slave ID is just 1. Okay. We should see this little connection down here at the bottom. And if we click on this connection, we need to set up the device tags that we're going to be connecting back to. All right. And this is talking about what we were just referring to before. So the first one we want is that tank valve open. So let's do a plus. And in the tag name, we're going to call it our tank valve open. And this is the registers. And so registers, there will be our coils, and these could be read-write, they could be read-only. We could see holding registers that are there, digital inputs, input registers here. These are all correlating back to that IW, QA, that kind of thing that you saw in the OpenPLC program. So we're going to work on our coil status to get started. Our Boolean type down here. And then the address offset is 1 in this case. And then we'll need to go ahead and add another tag for our tank level. And this one is a input register. And it is a int 16. So a 16-bit integer. Address offset of 81. And we'll show you how that correlates here in a little bit. Let's see, if we go back to our editor, and then if we click on this graph here, we can click on the property. And this is where we're going to set it back to the tag that we just created coming actually off the PLC. So this is where you're marrying the incoming data. We'll change this from progress 1 to tank fill LIT. And in our tag, we're going to marry that back to our tank level that we associated before. Hit OK. In that bar gauge, we need to set a max and min. So remember, our tank was kind of designed to have a minimum of 0 and a max of 10. This would all be information that you would get out of the sensors or your PLC controller as to what those ranges are so that you could marry them up with your HMI interface in here to set those sections. All right, we would need to go ahead and click on our tank valve here. And we're going to click on this duplicate one here. And we're going to move this down. We need to go on the line, and we're going to duplicate that. And also on our line here. Okay. See if I can get this little line. There we go. Duplicate that. And so what I'm going to do here is basically recreate what we have down below. And the idea is we want to fill that color so that when it's on, we can actually visually show them that it's a different color. So if I've got this one here, grab my little icon. I zoomed in too far here. All right, arrow keys for the win. All right, so let's take this, flip this guy around. Perfect. That's already got them both together. Even better. Okay. There we go. And so from that duplicated one, we want to click on this one here. We'll set our property. And under actions, we want to click on our add. And so the first tag is going to be set to our tank valve open. Hit OK. And our minimum here is going to be set to 0 with our max to 0, indicating it's on, in which case we're going to hide this one. And this one will also use tank valve open. And this one, of course, I'd set it right there. We'll set this to 1. And so this will indicate that it's actually turned on. And so we want to actually show this one here. All right. And then we'll complete the same process for this rectangle. Again, with this set to 0, and we will be hiding during that. And 1, we end up showing it. Okay. And then we can kind of set our dark gray color. So for these, we're going to click on these 3 here. Do it this way. Click on this one. And we could go to like this little dark blue. This one here. Let's go with the dark blue. And of course, our line could be dark blue as well. Okay. And then we're going to end up moving this over the top of our existing valve down here. Hopefully I got it somewhat to line up. That's pretty close. And so the idea is when the valve's on, it will show that it's on, and if it's off, it'll end up hiding it down below there. So let's go ahead and set up our connections again. And we'll go ahead and turn this section on. Make sure we got the green light, which means we're receiving data. Go back to our editor. And we'll go ahead and run our simulation. And we can see at this point that the blue is on, which means we must be set up for us to see what's going on there. And we can see our tank level is set to 6 here, right? So we can see we're almost getting up to the top, which it did, and it turned this valve off and everything worked through there. Now it's going to slowly drain back down and go in there as well. We'll also need to play a little bit with our pipe. but at the most part, we can see how it's going through there, right? So we could set these with properties of on as well, and then that would adjust that and allow us to build the nice little display that we had in the last lab there. All right, that brings us to lab 6, which will really kind of get us playing with some of the Modbus stuff. We'll let that load up there. So again, from here on out, the idea, labs 1 through 5 is really for you to be able to implement in the classroom. Students can go off and play. You can design, you could give them a graphic and say, okay, I want you to rebuild this graphic, and they can utilize these tools to do it, whether they want to do this in the lab environment, or you just have them go out here to GitHub and pull down Fuxa and run it locally, right? You could run it on a local system. It's really easy to deploy. It's just a simple web server that comes through there. They do have a nice little Docker Compose file. So if you're familiar with Docker, how many of you understand Docker and Docker Compose? Carl's there. Tom. Okay. So about 3 or 4 of you. That's good, bad. That tells me where I need to be here for Wednesday, is a lot of that was going to be based in Docker or building out virtual machines. How many of you guys are familiar with building virtual machines and have dealt with some kind of virtualization of some sort? So whether that's VMware Workstation, whether that's something else in between. Okay, good. We at least have some more hands on that regard for the virtualization side. Perfect. How many of you are familiar, if I have you clear your hands, how many of you are familiar with Proxmox, QEMU, that type of virtualization? Okay, about 1 or 2 at this point. I assume the rest of you are more familiar with VMware Workstation, ESXi? Okay, great. And that was really great while we had free access to everything, right? So unfortunately, that's not the case anymore. A bunch of schools are shifting to different types of virtualization platforms. At NDG, we decided to go after Proxmox, which runs a KVM, QEMU type virtualization product, and that's going to help move us forward in the realm. Plus, it's free, so we don't have to worry about licensing and things like that, like we did with the VMware side of things. VMware was great partners. I love VMware. I've worked with them for many, many years, clear back to when the academy was there. I was actually the contractor that worked with NDG and VMware when we wrote the first labs of using VMware to teach VMware. I was a part of that original section there. So let's see, James, did I get you put in here? I saw you. Yep, I got you marked off for the afternoon. So the only ones I'm missing is Terry Holloman, which doesn't look like I have one. Fred Keller doesn't look like I ever had here. And then David Rossi, I don't see. They came back after lunch. Okay. Great. Got everybody else checked in. So yes, VMware Workstation, VirtualBox is another one that's good for the desktop side. Most of what I'm going to demo this week is going to be in the Proxmox side, only because for those of you that do have NetLab systems or want to utilize it to build custom labs, custom curriculum content, that is kind of the new backend infrastructure. Plus, it is also free. So if you in your classroom want to run a little bit of virtualization, Proxmox is definitely what I would recommend for that, because you can utilize some really old hardware. You don't have the CPU and processor limitations that you would have to have like in the ESXi side of the house. And trust me, it's taken me a little bit to get converted over. But I do thoroughly enjoy the Proxmox now over even what I had with ESXi. It's definitely got a lot more flexibility to it, and some future growth that can be used there. So it's good to know everybody's background. We're going to be a little bit all over the place this week in terms of skill set. I'm happy to show you from scratch when we build out some of these virtual machines. And that way you could utilize those in the classroom. My goal at the end of this is you guys will have access to all things that we build in this class. So whether it's a CTF or whether it's a CTFD instance, and if you need to host that for your class or you want to use it this fall and are not familiar with how to do that, I'll even host some of that for free on my side. That's not a problem. All right. So let's take a look here at Lab 6, because this is where we really get into what Modbus is, and that's one of the main protocols that we'll be working with in this lab environment. And so we'll cover both Modbus TCP and Modbus RTU. All right, so a protocol is usually just a generic means of communication. Doesn't matter whether we're talking about SCADA or something else. But in a SCADA system, you're going to have a lot of different components, and that'll be things like workstations, application servers, the historians, and any other kind of equipment like our PLCs, our RTUs, even the intelligent electronic devices. Modbus is probably the most common one used in industrial protocols. RTU is referring back to the remote terminal units. So transmission control protocol, right? We've got that one. RTU is just another unit that's non-Ethernet based, but uses a very similar type structure in there. And so all those, they're all protocols. They all have different uses, right? And so Modbus protocol defines how data should be organized for systems to interpret that and how to be able to communicate with one another, while the TCP and RTU transmission protocols are methods of transporting that information across. So if you think of how humans communicate, Modbus is a language, while transmission protocols are the method of communication. And so our industrial protocols would be something like Ethernet IP, DNP3, or Profinet. In previous labs, we talked about Modbus communications, and that's really what this lab is going to be focused on. And so Modbus is how we were communicating with our other PLC program we were just in. So if we look at it from the OSI layer, this is kind of a comparison between the two. Modbus TCP is going to work on up through layer 3. And then your Modbus RTU kind of goes up just to the data link layer, right? So we're not having any kind of TCP layer or any IP type things in Modbus RTU. It's just a real simple serial-based communication protocol. So you may have seen this on some old equipment, right? You have that old RS-485 serial connection, or maybe that RS-232. Think your old school mouse, things like that. Those use this very low-level data link connection. If you remember Cisco switches and routers, right? We all have the console port. And that console port is using something that would be at this low level, this RS-232. So it's very, very similar. On the TCP is where we get into more IP-focused stacks. So within Modbus RTU, this was a real simple serial communication. It's meant to transmit binary data 1 bit at a time. That serial network would be used in industrial applications where data is needed, but not time critical to get that information. And so older industrial applications tend to have serial communication interfaces, but Modbus RTU is still an option for many of those industrial control devices due to its prevalence out in those systems. And so it uses a primary secondary architecture where Modbus primary is the polar, and that pulls the Modbus secondaries with either read or write requests. And then the Modbus secondaries will respond to those requests of the primary itself. And so each Modbus primary on a Modbus RTU network will have a unique address. The physical layer for the Modbus RTU can be either RS-232 for single node networks or maybe a 485 for multi-node networks. Think of it like token ring almost back and then, and how they had to communicate over those serial connections. So if it was just a simple one host thing, a simple serial connection, RS-232 or 485, which had more layers, more wires in the connection, allowed us to transmit more data across the line. Modbus TCP IP is going to be standard for the parallel communications based over Ethernet. It's essentially consists of industrial devices with individual IP addresses, much like what we're used to today. Instead of just IP, it's going to be Modbus going through there, right? So the physical layer of Modbus TCP IP is just the Ethernet protocol as we're used to it. Modbus clients will then pull each Modbus server on the network with either read or write requests. And in a SCADA system like the HMI, is the Modbus client, which pulls each Modbus server, usually pulling through there like the PLC side. So we kind of flip those around if you see what I'm saying. The PLCs are the quote Modbus servers. They're serving up the data, and the client, being the HMI, is pulling that information out of the PLC controller. You can see that kind of here, right? In a Modbus frame, it's a very small frame as it goes through there. So you're going to have your additional address that comes through here. Your PDU is going to be in this section here. This is going to ask for the function code, the data that's associated with that, and maybe some error checking. You'll have some primary IDs that come out of there in the RTU side of things. And then on the TCP side, you'll get some vendor information here, like the transaction, the protocol, the length of the unit. We're not going to tear down in this, and no, this will not be on the quiz, but it's good to know what's going under the hood there. And thankfully, things like we're used to, Wireshark is going to show up pretty easily in here. So when a client on the PLC does a rewrite request, the client has to know what kind of object data it's looking for, whether is it a coil, an input, a contactor, or is it looking for access, and what action should we be doing on the far side with that information. And that data about objects is captured on the client as memory in the form of a Modbus frame. And so to ensure the HMI is reading or writing to the PLC about the correct object, function codes are end up using to define what type of action you're going to take on that data. So in a Modbus frame, in the previous one that we saw there, notice the function code precedes the actual block of data. And so this table is going to show us all the Modbus function codes as they come up there. So to read a coil, we send code 01 with a bit size of 1. We would want to read a discrete input. It's code 02 with a single bit size. If we want to read holding registers, that's code 03, and we have a 16-bit integer over there. On read input registers, code 4, 16-bit. Writing to a coil, aka writing this information there, is an 05 with a bit size of 1. Writing to that single holding register, 06. And then if you want to write to multiple coils, you send code 15 along with a 16-bit size. Basically, you're going to set the bits for that. And on the multiple holding registers, we can write that with a code 16 going out there. I say all this because we're going to play with this here in a little bit and be able to interact with that. And so in OpenPLC, it defines a range of PLC addresses and then ends up binding them to the memory itself on the Modbus client. And so the client can use addresses to find that memory and pull that information back. So for example, on our discrete output coils or any discrete outputs, that is in the PLC address space of this QXO.0 all the way to 99.7. That gives us up to 0 to 799 Modbus registers that we can pull, and those all have a range of 0 to 1, aka on-offs. They're digital inputs, in this case, digital outputs that come out from there. If we want to set our discrete output coils, again, this is going to be this QX100 to 199, and again, we can set this in there as well. This is kind of more higher end outputs, primary stuff. We got to bump up to a higher address space. Discrete coils, and then you can see our holding registers down here. So these tables are pretty handy. Thankfully, they're built into the lab, so you don't have to reference them as hard. But when we start playing with them and we want to set up attack vectors, we want to overwrite this information on a controller, we have to know what kind of PLC address we want to attach to, and also what kind of value we would like to overwrite for that. So we're going to start by firing up our SCADA VM. I promise you it gets real fun here real fast. where we can start breaking things in real time. This is where the students really start to like it, right? So we built our stuff. Yeah, we understand a little bit about OT, but show us how to hack it, show us how to break it. And so that's what we're getting into now. But before we can run, we have to walk. And so it's nice to understand these protocols before we figure out how we're going to hack them. All right, so our SCADA system, we'll want to go ahead and load up a piece of software here, the FUXA. And we'll load up our Firefox and get our HMI up and going. And you're going to end up doing these steps quite a bit at the repeat at the end of these labs. That's just so that we could get everything up and loaded. So we're going to load up our simple little project that we've been playing with, our tank fill test. And then we need to turn on our PLC controller. Let this boot up here. It looks like we're all trying to hit it at the same time. So it should boot up our online service. There we go. Oops. Skip the step. There we go. And again, we're going to use that very simple tank fill sim one there. Okay, again, if you don't see it go to status there, just hit stop and refresh, and it should go back to the running status. Not a problem. Okay, we talked a little bit about this monitoring tab. And so again, this allows us to see those hardware addresses that we were just talking about. And so you'll note that we have this 00 address is where we can tell our tank valve to either be on or off. And you'll notice this IW80 is where we pull in our current tank level going through there. Okay. Let's go back to our SCADA VM. Click on settings. Our connections. We'll go ahead and click on this connection down here. Whoops, wrong one. It's my fault. Back to the other. Meant to click on the pencil there. And on this pencil, we'll need to adjust that to point to that PLC controller. We got our green dot, meaning communication's working. And if we look at our device tags here, these are the ones that our HMI is actually working with. So if we look at our tank valve, we can see address 1 going across very much to what we just set up in the last section there. Let's go ahead and set up our editor. And we'll go ahead and start this one. And we can tell our communication's working, right? So our tank is filling up. We can see what's going on there. and it shut it off and keeps going through there. So it's pretty cool. So now what we're going to do is we're going to load up our Kali Linux box. And at this point, Kali Linux is on the same network as everything, as we're just trying to get everybody described. So you'll notice Kali is sitting right here next to the SCADA VM, and then it's still going through the firewall down to the PLC. Let's see, if you're getting a open PLC connection error, more than likely, are you seeing that on the SCADA side, Terry, or are you seeing that on this side here? On the SCADA side, if you're not seeing that connection, more than likely this PLC is not up and running. So double check and make sure you got status running. And then on SCADA and that interface, make sure you have the this section here, settings, connections, the pencil, and make sure you have 502 in here. That's usually the common issue, is forgetting that 502 with that address. You should be getting this to go to green down here at the bottom once it works. All right, so we need to set up this Kali box to be on the right networks. So what we want to do is disconnect our connections for 2 and for 1. That puts us on the same network as the SCADA system that we talked about before. And so we're going to play a little bit with Wireshark to see how that traffic is going in between the PLC and the actual HMI interface, the SCADA controller. So if we come down here to 09 and then Wireshark, make this full screen so we can play a little bit with it. And we'll go over to our ETH2. We can see some traffic going. And we got a little bit of traffic pulling out there. Great. And if we apply in our filter section here, we would type in Modbus. Should go green. And we can see that Modbus traffic kind of going through there. So let's go ahead and stop this section. And then we'll start a new capture, continue without saving. We can grab this. And after a short period of time, we'll go ahead and hit stop. And so what we're looking for is one of these response queries that comes out. And if we look at a response query, that's going to give us some nice information. We can expand this Modbus, and we can see the bits that it's actually being sent there. So on bit 1, we can see a true and false. This one is also set to false. And we can kind of read those input registers as we go through there. What we're looking for is one of these response codes that's using a function code of read register inputs. Notice this one's reading the coils. Let's read our input registers. So that would be this one here. And here we can see it's referencing that number 80 and a word count of 1 as it goes through there. And we can see some of the stuff that's going in there with that 80. We can pull in that register 80. This one wasn't quite doing it. Let's pull in this one. There we go. This register 80 is a 16-bit integer, and we can see that current value is set to 2. And if we were to put that side by side with what we saw on our SCADA box, I want to do that over here a little bit. Give me a second to get this side by side. It's a little easier to see that way. Okay, and let's go to our editor. Actually, it's just this other screen here. That one, but this one. There we go. We can see this 7 and such here. This integer that we pulled out here, this was when it was at 2. And if we come back and look at the next time we see it, we can see it's at 2. We find the next one, still at 2, 2, 2. Notice we're pulling every so often. So we're trying to look for one that actually cranks that up a little bit. may have shut it off before I did that. Let's come down here. There we go. Now it's up to 3 as it goes through there. So if I was to start this up again, we should see 5 on that one based off on the right. Now it's 4. So I'm going to stop saving, run this for a little bit. There's our 4. And there's our 3. Perfect. And so if I come over here on this side and I go back and scroll towards the top, look at that integer, I can see here it was set to 4. So we're able to decipher some of those packets as they're going across in Wireshark. This filter really makes that easy for us to kind of see what's going on. If I scroll to the bottom here and check that same one, we can see that it had dropped to 3, just like we had saw over here on the right-hand side. So Wireshark's a pretty useful tool for us to be able to kind of see what's going on here. We can check some other stats as they're going through there. So for example, that tank valve or that coil is one. We'll notice that if we look at this coil and that bit is currently set to false, that's when there's nothing actually running on the network or on this tank valve system, as well as that autofill command. We'll notice that that's currently turned off as it's going through here. So we can see these coils showing zeros there as well. On this discrete side, we can also see some bit numbers that come in there, and we can see that one is set to false there for that discrete input bit, and we can kind of analyze this. So does everybody see how we can use Wireshark along with Modbus and kind of see that traffic going between a SCADA system and a PLC controller? I didn't put everybody to sleep here in the afternoon, did we? I promise it's going to get exciting as we start launching some attacks and showing you how to play with this. But like I said, we got to walk a little bit before we can run, but we can definitely attack that. And so here you can see that this pump is turned back on. If I was to do a new capture over here, and then I do a stop, if I go look at those coils, we can see that they're now set to true for actually having that auto command set up there. So it's really kind of easy to kind of go through and read a little bit of these. Once you get familiar with how this all works on this side, you can use Wireshark to kind of sniff quite a bit of traffic out. All right, we're supposed to take a little break here at 3 o'clock. So let's go ahead and take, I believe I have it set for about a 15-minute break. Let me double check that. I'm pretty sure that's what it's meant for. Yep. So let's come back here because it's 3:11. Let's focus on about 3:30. Apologize for going a little bit over that, but I wanted to kind of get you guys that background. And then we are going to jump into Lab 7, where we can really get some of our IT skills in the OT environment and try to see what's going on in there. So hopefully everybody's able to follow along. I know it's always hard here in the afternoons in some of these workshops, especially when you're trying to digest a bunch of information that you may have never seen before. So yeah, Terry, a lot of CTFs are gone into the Wireshark side of the house, and so that's one thing that you'll do here in the next lab is really kind of work through a captured Wireshark file, and it's a great way to build some CTF challenges out of that. So one way for you to do that is to kind of craft your own packets that go through there. And so as a matter of fact, in this lab, it's going to have you utilize some free ICS packet captures that are out there. And then you can have the students, pull that down and analyze that to pull some answers out for a CTF. Matter of fact, we could definitely create that on Wednesday, a CTF based around one of these Wireshark analysis tools using Modbus and all the other protocols that we're going to do in the next lab. That'd actually be a cool capture the flag based around that. Let's see. Do you use TCP dump or HP3 for creating? Yeah, you could do that. Absolutely. So I've done TCP dumps. I've done HPing. As a matter of fact, you're going to use HPing in this lab set in order to create a denial of service. Yeah, Modbus is one that's great for doing the industrial control side. And like I said, there's a lot of industrial control packet captures already out there. So if you don't have a way of creating them from scratch, so to speak, there's some really good ones you can download. Yeah. We're actually going to use them in this lab here. As a matter of fact, let me see here. Let's see if I can pull that across. I just got to get my right screen. I got too many screens open. There we go. Oh, I'm going to pause the recording too. All right. Great. So at least half of you are familiar with the Kali distro. Great. With the hands down, how many of you are familiar with Backtrack? Okay, I just wanted to know how old everybody was. That's cool. In my day, it was called Backtrack, not Kali, right? So, and I feel like I'm old. I'm not that old, but I feel like I'm old, as I've been around this stuff for quite a while through school and being able to train and do these kind of stuff with students. So it was nice that they let me come back and teach, because honestly, I'm just a big kid, and the classroom has always been my friend. All right, so let's go back out here to our spoofing in Wireshark. And this time, like I said, we're going to open up some packet captures that are available. So if we come in here to our PCAPs folder, yeah, Backtrack. It's been a while. I used to have those on CDs in a nice, cool little binder, like I was somebody. It's a lot of times. You know, what I really wasted a lot on the Backtrack days was I used to have these little things called Bitcoin that would never amount to anything. And then I wasted a lot of those when I was playing with that stuff back in the day. Probably should have held on to those. All right, so there's 3 PCAP files out here. We talked a little bit about this here before the break. But these are PCAP files that are from Geek Lounge. This was part of a conference that was out there where they recorded a bunch of ICS traffic. And it's great for us instructors to be able to kind of reuse this to replay some stuff going on. So the one we want to play with first is this 21. We'll hit open. There you go, the old novel analyzer. Yeah. All right, so you can see in here, there's a ton of packets that are going through here. I forget how many total there was. What was it? There's just over 1.2 million packets in this file. So lots that we can analyze and lots that we can use to try to help dig out some stuff. So you asked whether or not there would be some HTTP stuff, and yeah, there's the option of it, but not a ton of it that you're going to see. But if we look at HTTP off basic, that filter is going to kind of crunch through there, and we can see where people were logging into local traffic on this network with that protocol. We come down here to the authorization. We can see a login here. Does anybody know what this is? Maybe if you haven't read the lab already, but does anybody know what this authorization is here? Or the type of encryption that's being used? Surely somebody recognizes this one here. Not ROT64, but you're close. All right, so one of the usual dead giveaways is a little equal sign at the end, right? So this is all base 64 encoded, and that's a pretty common encryption as we go through there. But it's very easy to reverse engineer. The reason they typically do this in base 64 is it's very easy to store in a database. So if you're writing low-level programs, you can store it in base 64. What's really cool is I can store the entire I don't know, PDF file as a base 64 file or a base 64 encryption in a database. And then I can actually pull back that base 64 out of a database, create that into a file, or basically, you know, send that ones or the output of that back to a file, and it becomes a PDF. So base 64 is a cool way for you to encode various bits of data, store it in a database, retrieve it out later. Even if it's not meant to be encrypted, it's very simple. In this case, it's building out the credentials. So in this case, they're logging into the system with the username admin and the password admin. So if we were to decrypt this, we could get that information out of there. So there's a couple different ways that we can try to figure out what that is. And so as Terry was saying there, he kind of went through the lab. If we open up our command line as we go through here, thankfully, Linux has a great way for us to play with this. So if we use echo and then we transfer this information in, which we can do, we can just double click, right click, copy that. We're going to steal it. Whoops, went to the other terminal. There we go. We got our echo, and I'm going to paste my clipboard, and it didn't copy anyway. All right, we'll just type it. YWRTAW 46. YWRTAW4 equals, and we're going to send that to base 64 -D, and obviously -D is going to be decode, right? So we're going to echo that nice little strand right out of our Wireshark, put that in there, and we can see we get admin. It looks like I probably missed a little character there. YWRTAW46. Ah, I did. It's not a T, it's a W or a Y. There we go. Admin. So we got those credentials back out of there. So we could use the base 64 to do that. And like I said, that's the great part about Linux is this base 64 thing is in there. So if I base 64 the word JSON, actually, sorry, it would be the input there. We could look at that. D is the decode, and we could send like a file to it or just standard output, etc. So we could do something like, get this up here. It would be like echo JSON to base 64. And that is the base 64 encoded version of the word JSON going through there. So it's a nice, easy way for us to use the command line to do this. There's lots of other cool ones that are out there. CyberChef was one that we mentioned there. We could use that. So out here on the desktop, this is one that's commonly used out there in capture the flag events to help students, you know, decode and bring some of this information going across there as well. So if we say from base 64, and then we were to type in our input over here at the top. So we're going to drag this over here, base 64. Here's our input. I'm going to cheat and try to copy this out of my terminal from earlier. There we go. And on the output, we can see we have our admin out there as well. So that's pretty easy to use those tools. Let's see here. We get a lot of cryptography type challenges. Yep, absolutely. And students I've had go through there as well on the Skills USA and some of the other ones. Yep. As a matter of fact, I helped to write a CTF here a while back with Skills USA, utilizing some of these labs out of NetLab stuff. So it was utilizing that other software that I talked about in the past. Pre-made PCAPs on the web with these kind of challenges. Yeah, we can try to go out and find some, or can we make them? Yeah, we can actually make them and create our own PCAP files as well. I can show you a tool that will allow us to generate some PCAP files. It's not fun, but it can definitely be done. I've generated some in the past to make up some PCAPs instead of having to generate the traffic and then record the traffic. It just built PCAP files for that. Okay. Sorry to get sidetracked there. But this will allow you to kind of use some of those authorization fields and pull that kind of information out. So if you scroll through some of that Wireshark stuff that we did and we look some other ones like this one here, you can see that it pulled the credentials for root, and be able to see all the different passwords that are going across the network. We can clear our filter up here at the top. And so the next one we're going to look at is doing any kind of HTTP request method. So HTTP request. And so in this case, we may want to look specifically at, like, say, GET or POST or anything else. You'll notice when we filter this down here, that got us down to about 5,800 packets. So we may want to filter out other little things going in there as well. So we're going to tweak this one to be ones that are just POST, because that's usually when we send credentials to a website, right? We use the POST method in order to do that. And so we filtered it down here to this 15 packets. And if we look specifically at packet 8331, and we scroll down here in this format, we can see that in the content, we have 39. You can also see it's a URL inflated. And if we click on that application, URL encoded, down here we have this HTML URL, and we can see that that form was encoded here. So username admin, password admin, going through the login form. So it's a way to see kind of HTML forms in clear text. Now, again, you would see this in an ICS network because it's really hard for these devices to do any form of encryption, right? They just don't have the processor for it. So if they have like a local web UI for uploading firmware and things like that, most of those are not going to be HTTPS because they simply can't handle the encryption of doing that kind of stuff. So that's kind of the good, the bad of an old ICS system, is a lot of times they're so old they simply can't handle having encryption set. Or if they do, it's very basic encryption, like a base 64 encoded password. If we look on this 9935, this one here, and we come down here and look at our cookie, we can also see in the cookie that we can grab usernames and passwords out of here. So for example, the account name is admin, and we can see our password come out here as well, right? And that password looks a little bit different. It obviously looks a little bit encrypted. And there's a couple of tools that we can use in Kali to try to figure out what type of encryption this one is. So from our command line, we can essentially echo that. So if we look at this and we steal this password here, I'm going to right click and copy. And let's say copy the value. There we go. Come out here. And then on our command line, we can use echo to send that particular password. So let me paste it. And note that we don't want that password portion before that. We just want the 3F. There we go. And Kali has a nice little tool called hash identifier. And so if we hit enter, we can see all the different possible hashes that this tool can identify. And if we read here down below, it should be coming back as a particular one, except I probably didn't type something correctly. So let me look here. Okay. Oh, that looks good. Interesting. Well, that's pretty accurate as to what it should do. Sure why. Oh, there we go. I'm missing the wrong thing here. Possible hash, MD5 or domain cache. I'm looking at the wrong section of this here. So more than likely, this little hash that we have is an MD5 hash, which is pretty common for doing simple little hash detections. Sorry about that. Getting caught up in there. And so if you look through the rest of the Wireshark stuff and kind of poke through some of these other hashes that you might see in here, for example, there's a 500 one. If we look down here at this GoVS form, we could pull some other ones. But you could also use Hashcat or John the Ripper. For the sake of time, there's a bunch of other hashes that you can find in here. And so you would see those in this nice little table. So admin, user, etc. So what's cool is, you know, if they don't have this information, they being the student, and we build this CTF on Wednesday for this style, we could have the student go through here and try to pull out all these hashes. They have to find them and then submit the hash in order to get the credit in the CTF, as well as what the cracked hash would be to get the next points in there too. So we can definitely do that in CTFD and show you how to build out those capture the flags. That's pretty easy. Great. Another one we can do, if we come out to this 9221 here, sorry, I grab the right one, 994, there we go. It's easier if you expand this one out. It's this one here. We can right click and go to follow, and we follow this HTTP stream. It'll take a little bit to load it up. There we go. And so if we look at this, we can see this is them logging into a screen, and they got the account name and the password showing up in here. So it's pretty easy for us to see what's going in there. We can also see that they're getting kind of a 302 redirect as they go through there. That generally implies that the credentials used were wrong, right? So we could go back through other packets and see if there's other ones where we get a 200 for OK. Sounds like another good capture the flag question and answer that we could bake in there as well on HTTP codes. So 302 a redirect, 200 is an OK response. So let's go ahead and close this guy out here. And if we look at other ones that are like that, we should find another packet that we can follow TCP stream on. And that would end up telling us a 200, which would give us a username and password out there in the main text. All right, we'll go ahead and flush our stream out there as well. And now we're going to look at FTP traffic that could be out there. So FTP, and again, FTP is used in the ICS world primarily for being able to download firmware is what we would see the most of that for. And again, they can't use FTPS or SSH or SFTP because they simply don't have that type of encryption, or the processors aren't good enough to do that. So as we look through here on FTP, we'll pull back up a packet 48883 like this one here. We can expand this file transfer protocol and see that they're doing this for an Axis camera. And this is a network camera. This is a pretty common camera used in industrial control systems in order for monitoring things that may be going on the network. All right. Because of this MAC address that's being pulled through here, we can see this here, AxisCom, which is produced by Access Network Cameras. We can also go through and look at, exploitdb.com and see if there's any exploits that were available for that particular camera running software version 440. Some of you may be familiar with tools out there that list all the cameras that are available for us to hack. I won't list that entirely there, but it's a great resource for students to be able to go out and learn whether or not some of their stuff is being exposed out to the internet or not, and then maybe without their knowledge. So we talked about Modbus in the past. Let's go out here and look a little bit on the Modbus side. And so unlike the Modbus stuff that we saw in the past, there's some queries out here but we're not seeing any kind of read input registers, which is what we saw in the last ones, right? So if we look at the Modbus, we can see that on the type here, we're getting basic identification stuff or read identification. These are 14 codes as they're going through here, which is different than those codes that we were looking at in our other packets. However, there's still some good information that can come out of there. For example, the function code is 43. We can see that, and we can see other different Modbus codes that we go through there. To see those, let's go ahead and go back to open. And we want to look at this last PCAP file here. All right. And so in this Modbus, we can see that there's significantly more Modbus packets in this PCAP, about 99,000 PCAP files that are going through there. And you can see all sorts of different function code results, right? So there's 17. There is a 43 again. If we go down and look at packet 5100, let's look there, 5100. Oh, I went way too far. Sorry about that. There we go. 079, so just right above this. There we go. We can see we finally got a read coil, which is like the one we saw in the past. And so if we read that bit, we can actually see that on bit count 1, we're pulling back some information there. So again, that function code is something that we're going to use in some later labs here on being able to figure out how to break into a system after we pulled some information. DNP3 is another language that we've talked about. So DNP3 is Distributed Network Protocol. It's another common open standard remote communications one used like Modbus and through there, and typically used in those process automations and SCADA systems. Used typically by electric and water companies is where you would see it the most. And it differs from Modbus in both it works as an application and the data link layers, which Modbus is just an application layer. So you can see some of these here. If we click on a packet like 825, something like this, DNP, we can see at the data link layer that we're getting information there. We can also look at the transport control layer and see that we're getting information that's being detailed there. So lots of different ways for us to pull quite a bit of information out of here. If we look at the data chunks and even these fragments, we can start to pull out application layer stuff that we would see here. So like here's a read layer. We can look at these objects, see if there's any kind of data that we want to parse out of these ones here using the same style bit registers that we're used to. All right, we also have ENIP. And again, ENIP is going to be our Ethernet/IP communication. That's kind of the leading industrial control protocol now that adapts kind of the SIP or Common Industrial Protocol over to Ethernet as well. And so there are only 5 packets available in this particular packet capture, but we can look at these headers and kind of see what's out there. So we have this option to do a list identity. And we look at this encapsulation header and we can get some information back here. If we look at these unknown commands, we can see some of that being pulled out here too. We're going to dive into those a little bit later when we start emulating our own. Another one is F7, and S7COM is another one that's pretty good by Siemens, which is their own proprietary protocol and usually runs between PLCs and their SCADA controllers as they kind of go through there. And so in this one here for their setup, we can look at our Ethernet 2 and we can see that we have a Siemens MAC address that's being pulled out here. And we can look at our source and destinations field as we go through. What this is going to do is tell us what kind of packets that we're end up going through there. So for example, this 276411, That 01C portion, 001C06 portion refers to Siemens numerical control, and they manufacture industrial control systems for computer numerical controls, CNC machines. And so we can infer from this information that this is a Siemens automation control system sending packets out to a Siemens PLC there. Yeah, it is, Terry. It's one of their main function codes that you can go against. Yep. And so if we look at the address here and we look at the S7 communication, we can see it does a very similar function here where their function code is 0x04. That allows us to read variables. And if we look at the data, we can see that we can get return codes, in this case, successes, over this S7 data. So basically, it did a read variable for 5. That's what that item count is. That got us back 5 different parameters from there. Okay. And we can dive into that. So it's a good little Wireshark lab for students to get, they have these, typically are you guys teaching Wireshark in some of your IT classes? That's a good question. So raise your hand if you guys are teaching or utilizing Wireshark in your IT classes. Good. So 4, 5, 6, 7. Good. About at least half of you, most of you are using Wireshark in there. And I strongly suggest it, right? I mean, just the other day I was trying to troubleshoot a bug with the back end of NetLab and Proxmox and some other stuff. And sure enough, just run TCP dump and dump a file and then load her up into Wireshark so you can kind of analyze the packets. So it's a really useful tool. And it translates over to the industrial control or the critical infrastructure side of the house, because if you're trying to see these type of packets go through there, or worse yet, you're trying to protect some of these packets that go through there, you really need to see what's going on in the network first. Like I said, when we start going through and attacking industrial control systems, we can very easily break the systems doing what we would normally do in IT, right? So in IT, we use things like Nmap, right? And all we're going to do is just do a simple ping sweep across the network and see what devices respond. Well, that simple little ping sweep in an industrial control network can absolutely crater a PLC. So you have to be very careful when you're doing those kind of audits, or if you're doing tests or changes or stuff like that, things we take for granted in the IT side of the house, the OT side, you can very much take down those systems. Matter of fact, there's going to be a lab coming up for that. So, all right, let's go ahead and close this lab down. And we'll go into lab 8 here. So if I recall, lab 8 kind of sets us up for the rest of the side of this. It's been a bit. I say it's been a while since we wrote these. I wrote them, what were these, 2 years ago now at this point, so it's been a while. I was really hot and heavy into it here about 2 years ago, trying to get this built out with this group. So try to give me some feedback. How are you guys liking the workshop so far? Is this the kind of stuff you were looking for ICS? Are you at least getting some information that you didn't know before? Okay, great. Great. It's always hard to judge everybody when you can't see faces and all that kind of stuff, right? So I appreciate you guys giving me some thumbs up and some feedback in the chat. It makes it helpful. That's great. Thanks again for that feedback, because I really, like I say, can't tell if everybody's enjoying the content or not. It was easier in the classroom last year, that's for sure. Okay. So this lab, we're going to dive a little bit deeper into some of those protocols that you guys got to see there. And in this case, what we're going to do is actually modify some of those protocols on the fly. and show you just how easy it is for us to be able to edit those, because nothing's encrypted for the most part in the ICS network. So let's go ahead and fire this system up here. We're going to be using our CaliBox again, our PLC, and our SCADA system to kind of see what's all going on. So we're going to start by loading up a PLC program so we have something to work with. And it's going to be very similar to the one that we've been doing all along here. So open PLC, open PLC. Yeah, that's interesting, Tom. I'd be curious to see what the output of that was, because that's pretty interesting. That's really what I like to do in a workshop, right? I like to get everybody involved. I know some of you are trying to do two things at once right now. You're listening to me, but you're also trying to course prep because classes start in 30 days. And some of you will wait 3 weeks like I do and then try to do it on the Sunday before classes start. It's okay. You're not the only one. So I get it, but I definitely like to get, for the ones that want to be hands-on and interact and share resources, that kind of stuff, I definitely want to make sure you get your value out of the workshop here. All right. So this time around, we're going to use the advanced one here. Upload this program. And we'll call it the advanced tank fill. Everything should load up okay. Great. And we'll go ahead and start our program, make sure it launches up. Looks like we got to running, and it's listening out here on all these different protocols like we talked about before. We'll go ahead and click on the monitoring tab just to make sure. And it looks like that tank's about to start filling up, for which now the tank is open and it's going ahead and doing its autofill. So one thing that's handy is it's going to, again, give you this table so you're kind of familiar with what's all going on and what all those different points are. Again, the e-stop is the emergency command. This tank valve open is determining whether it's open or closed. Our current level that's coming out of there, our high alarms, auto commands, and our current status as these come through here. Notice this is kind of the Modbus data location versus the PLC address. So the PLC says I'm storing this in my QW16 memory register, which just so happens to align to the Modbus 16 data register as it comes through. And that currently has a set value of 8 from the PLC controller. All right. So now let's fire up our HMI, or our SCADA there. So let's go to our SCADA. And from the SCADA side, we're going to use a little utility called MBT Get. And MBT Get is just a way for us to interact with Modbus packets. It allows us to send one direction communication with Modbus, and then we can retrieve some values out of it. So it's pretty easy to get with. We're going to go MBT Get -R4-A80, and then we're going to send the IP address of our PLC controller. Whoop, that picked up 2 R's there. There we go. And we can see the value of 7. And if I do this again, we can see it got to 8. And now it's 7. So as you see this, it got to 8 and falling back down. Can any of you guess which number we just pulled out of here? Does say it in the lab. Tank level, right? So this is monitoring our tank level, and this is a way for us to see it right on the screen. And all we're doing is pulling that PLC controller. That PLC doesn't have a username or password. It's just hosting information. All we have to do is pull those numbers from it. And that's what we're doing with this R4 in order to read that particular register. All right. We go out here to Kali. And let's log in here. Again, we need to disable the networks we're not using on Kali so we don't have issues. So we'll disable 1 and 2. And then over here, we can use IP add just to make sure that we're set up on the right network. We should be this 2.5. We look at our topology. We made sure we're over here on the 2 network with 5. So we got our interfaces set up correctly. And we're going to go ahead and load up Wireshark here. And we'll focus on Ethernet 2. And then we're going to go back to the SCADA tab. And we're going to go ahead and run this Git again. And we should see a 6 that came out of there. We'll flip over to our Kali tab. We can stop our recording. Just like that. And then if we do a Modbus filter in here, we can see when we punched out that query. So this was a query, and we can see our function code was 4. That's the R4. So read function 4. We can blow up our Modbus down here and see that exact code that we did there. We referenced 80. So we wanted to pull the information out of 80. And we got 1 word count back. Our 1 word count is what we're calling for. That is our query. If we look at our response, we can see from 80, we got a unit 16, and it ends up being a 6, right? And so that matches exactly what we did when we did the request out here for getting that information from the SCADA system. So we can end up pulling all those type of identification packets if we wanted to. And we can see more and more about what's going on in our network there. Okay. If we go back to our SCADA tab here, and we want to run some of these other commands, we can do that. So for example, if we want to figure out our current tank status, that would be R1A0 in order to get that data store. If we want to see our tank level alarm, we could pull that. When our tank is full, we could pull those R commands. And each one of these is telling you what it's trying to do. So R1 is going to read a bit, which is for discrete coils. If we're looking to look at the hold registers, we have to use an R3, which is to read a word value to pull some memory out of there. That would be like this R3 here. It's a bigger value, so we need to pull it out. And then R4 is used for reading actual words for analog input registers as they're coming through there. So. But like I said, you could test and you can play with a couple of these MBT gets in order to get some of those values out. So that was to read all of those packets, but we could also use MBT get in order to write packets there as well. And because in this environment, there is nothing keeping us from writing values from the PLC controller. Most of those systems don't have forms of authentication in the early days. Because they were all on secluded networks. They didn't have to worry about people breaking in at that point. So if we go and look at those, we could do something like MBT get -R3 -A32. And this would be again to our PLC controller. And we can see that I can't type. MBT get, there we go. And we get a 2 back, right? And so if you went and played with this, remember this is reading, in this case, the value for tank empty set point. So right now it has a value of 2. When the tank gets down to 2, the system's going to go ahead and stop at that point, right? If we wanted to write this, we could see that we never get the alarm, right? If you guys remember the alarm setting, we go back here and look at the PLC and our password. You'll notice that we never trigger this alarm, and that's because the tank never falls below 2. That's our set point right here. It just hit 2. It immediately turned this on, and therefore it never falls down to 1 in order to trigger this low alarm. So if we wanted to make sure that we trigger that low alarm, we could go out here, look at our Modbus. We can go to SCADA. In this case, we're just going to start a new packet capture. Let's go out to our SCADA, and this time we're going to write that out. So if we do an MBT get W6 on that A32, and we want to write a 0 to that and hit enter, we see that we were able to write to that PLC controller using Modbus. What that's going to allow us to do is go back to our PLC, and you'll notice our tank level is now at 6. We can see our tank empty is now set to 0. So what we should see is this is going to hit 5. 4. 3. And there's our 2. Notice how it did not turn on the tank valve, right? Because now our set point is 0. So it's going to keep draining. Now we hit 1. Now all of a sudden we triggered our low level alarm, in which case it's going to drain down to 0. And once we hit 0, it goes ahead and turns the valve on. Our auto command initially runs. Our low level alarm is still on because we're still at 1. There we hit 2. So now our alarm goes off, and it will go ahead and fill all the way back up to 8. Okay. So that's interesting. Let's go over here to Kali. Let's go ahead and hit stop on this Modbus, and we should see a packet here. And this is where we actually wrote the packet out, right? So we can see a single register write, and we can see the response that we wrote it out to 32, which is the reference number for that particular coil that we wanted to write that out to. So pretty simple. If we come out here to our PLC, we're going to go ahead and stop our program. There we go. And so in that protocol there, we noticed that Ethernet over IP isn't really fully implemented in this software. So we're going to need to emulate Ethernet IP kind of running over a different program. And thankfully, there's a nice little Python project that allows us to do that. So if we come out here to our documents folder and we look at ENIP, and inside ENIP, we're going to have a CPPO config file. If we do an ls, we see that there. And let's go ahead and cat that file. And this is going to give us some information about this particular system. So in this configuration file, it's going to allow this PLC system to act as a PLC device running on this IP address of 1.30. As opposed to the 1.10 of this actual VM itself. We're going to make it listen on 1.30. And you'll notice that we are making it emulate. It is a Logix 555 PLC controller. So we can actually modify some of these serial numbers and product names and basically write our own PLC controller to act on the network. And then you can use Python in order to serve up this particular system. So if we use Python 3-m cppo .server.enip, and then we're going to set some values here so we can see what's going on. And we can see we basically fired up our own little PLC controller down here, and it's now up and running on all Ethernets on this case, on this interface. And so what that would allow us to do is actually go out to our SCADA system. And here we can use the same Python project in order to pull that system as if we are running our FUXA interface or something like that. So we have Python 3 -mcppo server.inip ip.pull. And on the TCP IP side, on the identity, we want to pull that device that we had before. So 1.10. And if it works, we should be able to start getting traffic from that device. And we can see that we are getting traffic successfully coming out of our little device there, right? And so it's currently pulling. If we go back over to our PLC controller, we can see those requests coming in from our SCADA system, as this will continue to kind of chunk through there as it's pulling those devices, all right? So that's gathering the identity tag. We could go ahead and go back over to Kali, and we can stop our recording, which I wasn't doing. So let's just start it real quick. And we can clear our Modbus tag. Let's let it record a little bit. Great. We'll go ahead and stop that. And then now we want to kind of filter out any of our ENIP traffic. So let's do that. And in this case, we're going to look specifically for our packets that come through here. We can do some filtering. And if we look at, let's see here, there's our ENIP. And under this ENIP that comes through here, we can look at our packets, command specific, encapsulation. We can see that we're pulling for registers going through there. What we really want to look for on one of these ENIPs is a success. So let's see if we can see that come through here. There's the list identity request. Response. Actually, we should see set protocol come through there. Just start up another one here and see if it runs a little longer. Should be getting some SIP protocol. And what it ends up doing is basically giving you this packet here. And that we would actually see that that one we're emulating is a Rockwell Automation or an Allen Bradley PLC. And that's a very big common brand of what's coming through on that side. So pretty easy for us to kind of pull that information out of there. All right. So we can stop our SCADA system and our PLC from pulling one another. Close that there. And our PLC. Great. And so what we want to do is kind of set our own tag and pull that through. So if I come back to this PLC, and this time around, we're going to use the same script. Only we're going to set a tribute tag called tank station. A. Okay. So now it's up and running and has set tags available for us. Back to our SCADA. And we're going to try to retrieve those attributes coming out of there. So instead of pulling, we're going to get attribute. And that same attribute that we tried to pull out of that system on 411. And you'll see we were able to pull out this single gas system that came out here. And it's basically just pulling the attribute that we had in our config file. We can pull out individual information out of that PLC system. All right, you'll notice that this current value is set to 0 on this side. We could also get the attribute out of there, and then we can set the attribute if we wanted to do so. And so to do that, we would do the same command that we ran before. Only we need to set that attribute, which is by doing this at 4111. Like that. And over here, we're going to set our integer for that one, int, oops, equal to 1. And if that works, which I didn't set that equal, sorry, I already had to equal there. There we go. And I still fat fingered something. Give me a second here. There we go. There we go. And so we can see it was set to 0, and now we set it over to 1. So there's some low-level commands that we can do to kind of play with some of this. We could set that back to 0 simply by going in and changing this integer command. And some of you on the tech side realize we can write some simple scripts to really bang these PLC systems and set values, unset values. We can do all sorts of things to manipulate what you would typically see on that side of it. You can also use the print take station, so we can actually pull some of these attributes back out on the Ethernet tags, but it's kind of interesting. We can, at a low level, do some of our IT stuff to really mess up some of these PLC controllers. All right. So we've got about 30, 40 minutes here for the end of today, and that's kind of where I want to pause because that gets us through talking about those lab controllers, and now we're really going to dive into the cybersecurity side of ICS systems and what we would do to run normal, scans, how we're going to create attacks on there. And you can see here on the screen that we're going to end up scanning these systems with a couple different tools, and we have to be careful because we can crash them. That we have to do, we're going to do a man-in-the-middle attack where we can actually break into the ICS system and simulate some information there. And then we're going to work our way in from the overall topology. If you guys remember that topology for this one, it looks like this. So eventually what we're going to do is use our cybersecurity side to break into this corporate workstation, right? And from that corporate workstation, we're going to try to pivot into that domain controller. And then from that domain controller, we're going to find a way into this engineer's workstation. Once we get into that engineer's workstation, we can then reflect traffic back in order to attack the SCADA system and ultimately overwrite the values on the PLC so that we can end up overflowing the tank and watching it go haywire all over the place, right? So some pretty cool attacks that we're going to end up doing. That includes setting up command and control center stuff so that we have remote access that's persistent across the network. Remember, these are the type of attacks that happened in that Florida attack that I talked about earlier. So it's a very slow, methodical style of attack. It's not something that happens overnight. And even if they reboot their system and think they cleaned it up, we actually have some backdoors where it automatically phones back to us. And this is the basis of what you see a lot of attack vectors set up today on the Windows side. And so you typically see Windows in these environments. Unfortunately, that's why we had to run Windows here. Now, normally you would see Windows Desktop. In this particular environment, you're going to see Windows Server for these. That's just a licensing thing. We can't license Windows Desktop, but normally you would be able to run these on like Windows 10, Windows XP, et cetera, et cetera. So I really want to kind of load that up tomorrow. We're going to run through 9 through 14, and that'll really get all your black hat testing skills in for tomorrow. With that, what I'd really like to do with the last 30 minutes, I guess we actually have about an hour, don't we? And that's okay. Because I was told I had to use the entire time, but I don't want to get too far ahead from tomorrow. What I'd like to take the last hour today is really just to have everybody kind of come off mute. I'm going to end up stopping the recording. Let me go ahead and do that.